Picture this moment. Dawn breaks across the highest peaks on Earth. The first light touches snow that has remained untouched for centuries. Silence stretches across valleys so deep they seem to disappear into the planet itself. Here, where the air grows thin and the world falls away, the Himalayas stand as monuments to time itself. These mountains rise like ancient guardians. Their faces are carved by wind and weather, their secrets locked beneath layers of ice and stone. For millions of years, they have watched over the world below, silent witnesses to the rise and fall of civilizations, keepers of mysteries that may never be told. The morning mist clings to distant ridges. It moves like breath across the landscape, slow and steady, ancient and eternal. In these moments, between darkness and light, the mountains seem to whisper, not words that human ears can understand, but something deeper, something older than language itself. Each peak tells a story. Each valley holds a memory. The snow reflects sunlight that has traveled across the cosmos to reach this place. The same light that warmed ancient peoples who may have walked these heights long before recorded history began, before the first written word, before the first carved stone. What secrets lie buried beneath this frozen wilderness? What stories remain untold in valleys where no modern foot has stepped? The Himalayas stretch across the horizon like a wall between worlds, between the known and the unknown, between what we understand and what we can only imagine. Scientists speak of geological processes, of tectonic plates that crashed together millions of years ago, of forces so powerful they lifted the ocean floor to touch the sky. But perhaps there is more to this story. Perhaps these mountains hold memories of civilizations lost to time, of knowledge buried beneath the ice, of wisdom preserved in stone. The wind carries stories across the peaks, stories of explorers who vanished without a trace, of temples hidden in caves that no map has ever marked, of lights seen dancing across the snow on moonless nights, of footprints found at impossible altitudes, footprints that belong to no known creature. In the quiet moments before full sunrise, the mountains seem alive, ancient and watchful, as if they are waiting for someone to ask the right questions, to look beyond the obvious explanations, to consider that perhaps the greatest mysteries of our world are not found in distant galaxies or deep ocean trenches, but here, in these peaks that touch the sky. The Himalayas hold their secrets close. They have learned patience over millions of years. They know that truth reveals itself slowly, like snow melting in spring, drop by drop, layer by layer. Each revelation is more precious than the last. As the sun climbs higher, shadows retreat into hidden valleys. But the mystery remains. It lives in the spaces between what we know and what we wonder, in the silence that speaks louder than words, in the ancient stones that have witnessed more than human memory can hold. What if these peaks hide something extraordinary? What if beneath the snow and ice lie answers to questions we have not yet learned to ask? The Himalayas stand ready to tell their story, to those patient enough to listen, brave enough to believe, curious enough to wonder what secrets the highest places on Earth might hold. Meanwhile, beneath these towering peaks, a story unfolds that spans geological time. The mainstream narrative speaks of immense forces, of continents drifting across the surface of the planet like ships on an ancient sea. 50 million years ago, the Indian subcontinent began its slow collision with Asia, a crash that continues today, millimeter by millimeter, year by year. This collision birthed the Himalayas. It pushed sediments that once lay at the bottom of ancient oceans toward the sky. Marine fossils now rest at elevations where eagles struggle to fly. Limestone formed in tropical seas sits frozen in permanent winter. The very stones beneath our feet tell of journeys across time and space that humble the human imagination. But geology reveals more than just the story of moving continents. It speaks of preservation. of landscapes locked in time. The violent birth of these mountains created pockets of space where ancient conditions might persist. Caves carved by water that flowed before humanity emerged. Valleys isolated from the changing world below, places where time moves differently. The process of mountain building creates unique environments. As rock layers fold and fracture, they form natural vaults, hidden chambers where temperature and humidity remain constant across centuries, where organic materials might survive far longer than conventional wisdom suggests, where evidence of ancient life could wait, preserved like manuscripts in a frozen library. Erosion works slowly at these altitudes. What might decay in decades at sea level could persist for millennia in the thin, cold air of the high Himalayas. The same conditions that challenge modern explorers might serve as perfect preservation chambers for materials from the distant past. Ice forms natural seals. Rock provides shelter. Altitude offers protection from the destructive forces of the lower world. Consider the implications of such preservation. If human activity occurred in these regions during warmer periods in Earth's climate history, traces might remain. Tools, structures, art. The geological record shows that the Himalayas have experienced dramatic climate shifts. Times when valleys now locked in permanent ice enjoyed temperate conditions. When human settlement would have been possible at altitudes that seem impossible today. The ice cores extracted from Himalayan glaciers contain records of atmospheric conditions stretching back hundreds of thousands of years. Trapped within frozen layers are samples of ancient air, pollen from plants that grew in different climates, dust from volcanic eruptions that darken skies across continents. But what else might be preserved in this frozen archive? What organic traces of ancient life await discovery? Tectonic activity continues to reshape these mountains. Earthquakes expose new rock faces. Avalanches reveal previously hidden surfaces. Glacial movement uncovers materials that have been buried for millennia. Each geological event offers new possibilities for discovery, new windows into the deep past. The very instability that makes the Himalayas dangerous for modern travelers might explain the preservation of ancient secrets. Landslides could have buried settlements intact. Glacial advances might have sealed caves and valleys like time capsules. Tectonic shifts could have created hidden chambers where ancient peoples might have taken refuge during periods of climate catastrophe. As the planet's climate continues to change, these preservation systems face disruption. Glaciers retreat, exposing surfaces that have been hidden for millennia. Permafrost melts, releasing materials locked in frozen ground. The same processes that once protected ancient evidence now threaten to destroy it before it can be studied, creating a race against time for researchers seeking to understand what the mountains might reveal. The Himalayas represent more than just the result of continental collision. They stand as archives of Earth's deep history, natural museums where the past remains accessible to those who know how to read the geological record, where the story of ancient climate, ancient life, and perhaps ancient human activity waits to be discovered, layer by layer, stone by stone. Each revelation adds depth to our understanding of what these peaks might truly hold. Centuries earlier, before written history began to document the affairs of kingdoms and empires, the peoples of the Himalayas carried their memories and stories. Oral traditions passed from grandmother to grandchild, from shaman to apprentice, from traveler to traveler across the high mountain passes. These stories speak of times when the valleys knew different seasons, when rivers flowed where glaciers now reign, when cities thrived in places now lost beneath eternal snow. The Sherpa people tell of Bayul, hidden valleys where enlightened beings once dwelt, sanctuaries sealed from the outside world by natural barriers and supernatural protection. According to their traditions, these valleys exist in a state of preservation, waiting for times of great need, when the outside world becomes too dangerous or corrupt. These stories describe places where ancient wisdom remains intact, where the natural world provides abundantly, where time follows different rules. In the remote regions of Mustang, elders speak of the kingdom that vanished overnight, a civilization that reached heights of learning and prosperity before disappearing so completely that only stories remain. They describe palaces carved into cliff faces, libraries containing knowledge of sciences unknown to the modern world, astronomical instruments capable of calculations that challenge contemporary understanding. The Tibetan tradition preserves accounts of the Zhang Kingdom, a civilization that flourished in the western Himalayas long before recorded history. Archaeological evidence confirms that advanced settlements existed in this region, but the oral traditions describe capabilities far beyond what physical evidence has revealed. They speak of technologies for moving massive stones, of methods for carving tunnels through solid rock, of communication systems that spanned impossible distances across mountain ranges. Local legends from Nepal describe the Kerala people, an ancient civilization that understood the secrets of high-altitude survival. Stories tell of their ability to navigate in conditions that would challenge modern equipment, of their knowledge of cave systems that connected distant valleys, of their mastery of astronomy that allowed them to predict weather patterns seasons in advance. In the Kashmir region, folktales preserve memories of the Nagas, serpent beings associated with hidden knowledge and underground realms. While mainstream interpretation treats these as mythological symbols, the stories contain surprisingly specific geographical details. They describe access points to underground networks, water sources in locations that align with modern geological surveys, cave systems that match actual discoveries made centuries after the stories were first told. The consistency of certain details across different cultural traditions raises intriguing questions. Multiple societies, separated by geography and time, describe similar phenomena. Hidden valleys accessible only through secret passages. Ancient peoples who possessed knowledge of metallurgy and engineering that exceeded their supposed technological level. Structures built to alignments that demonstrate sophisticated astronomical understanding. These stories often describe civilizations that chose concealment over expansion. Peoples who deliberately withdrew from contact with the outside world, who sealed their settlements and took their knowledge with them into hidden refuges. The traditions suggest this withdrawal was not due to defeat or catastrophe, but rather a conscious choice to preserve their wisdom for future times. The oral histories describe methods of concealment that go beyond simple isolation. They speak of techniques for camouflaging structures so completely that they become invisible to casual observation, of entranceways disguised as natural rock formations, of settlements built within existing cave systems and expanded using methods that left no trace of artificial construction. Some traditions describe these hidden civilizations as maintaining contact with each other across vast distances. They speak of networks of communication and trade that operated without leaving the kinds of evidence that archaeologists typically seek, of knowledge preserved and shared through methods that bypassed written records entirely. As climate change alters the landscape of the Himalayas, some researchers wonder if these oral traditions might guide future discoveries. If the stories preserve actual geographical knowledge that could lead to physical evidence, the melting of ancient ice might reveal structures that have been hidden for millennia. The exposure of new cave systems might provide access to chambers that oral tradition has never forgotten, making these ancient stories more than mythology, turning them into maps leading toward extraordinary discoveries waiting in the world's highest places. But another possibility emerges from the mists of Himalayan folklore. Deep in the most remote valleys, where few humans dare to venture, footprints appear in virgin snow, large impressions that follow no pattern known to modern zoology. Tracks that suggest a creature walking upright across terrain that challenges even the most experienced mountaineers. The Yeti mystery extends far beyond simple folklore. It touches questions about what kinds of life might persist in the planet's most isolated places. The footprints tell a story that mainstream science struggles to explain. Discovered at altitudes where oxygen levels would challenge any known primate. Found in locations hundreds of miles from the nearest human settlement. Photographed and measured by credible witnesses who have no obvious motivation for deception. Mountaineers, scientists, expedition leaders who risk their reputations by reporting what they have seen. The Sherpa people distinguish between different types of unknown creatures. The Yeti represents only one category in their taxonomy of highland mysteries. They describe Micha, a smaller, more human-like being that avoids contact, but sometimes leaves evidence of its presence. Tools crafted from materials not used by local populations. Shelters built using techniques unknown to regional traditions. Fire patterns that suggest different methods of heat management and fuel consumption. In 1951, British explorer Eric Shipton photographed a footprint on the Menlong Glacier. The image shows a clear impression in snow, approximately 13 inches long, with toes that appear prehensile. The photograph underwent extensive analysis. Experts confirmed it was not a hoax, not a known animal print distorted by melting, not a human footprint altered by natural processes. It remains unexplained. A piece of physical evidence that challenges conventional understanding of Himalayan wildlife. Local hunters describe encounters with creatures that display intelligence beyond typical animal behavior. They report beings that seem to understand human presence and deliberately avoid contact. That moves through terrain in ways that suggest detailed knowledge of local geography. They appear to use tools and modify their environment in purposeful ways. These accounts describe behavior patterns that fall somewhere between animal instinct and human cognition. The mystery deepens when considering the possibility that such creatures might represent remnant populations of ancient human relatives. Species that adapted to high-altitude life through evolutionary pathways that diverge from mainstream human development. The Himalayan environment creates unique selective pressures, extreme cold, low oxygen, isolated territories where small populations might develop distinct characteristics while remaining hidden from outside observation. Genetic research has revealed that human evolution followed more complex pathways than previously understood. Recent discoveries show that multiple human species coexisted for extended periods. That interbreeding between different human types was more common than once believed. That population could remain isolated for thousands of years while developing unique adaptations to specific environments. The possibility of unknown primate species in remote regions is not scientifically impossible. New species continue to be discovered in isolated ecosystems. The archaeological macaque was first described by science in 2005, found in the same general region where Yeti sightings are reported. Large mammals can persist in small populations for extended periods without detection by mainstream zoology. Hair samples attributed to unknown creatures have yielded inconclusive results. Some show characteristics similar to known bears. Others display properties that do not match any cataloged species. DNA analysis has identified genetic sequences that appear to be contaminated or degraded beyond useful analysis, or representing unknown genetic combinations that challenge existing taxonomic categories. The infrastructure required to maintain hidden populations raises questions about intelligence and social organization. Unknown creatures would need shelter systems capable of protecting them from extreme weather, food acquisition strategies that work at high altitudes, methods for avoiding detection while maintaining breeding populations. These requirements suggest capabilities beyond simple animal survival instincts. As exploration technology advances, the possibility of resolving the Yeti mystery increases. Satellite imagery can identify heat signatures in locations where no known life should exist. Motion sensors can detect movement patterns that suggest large creature presence. DNA sampling techniques can identify species from environmental traces without requiring direct contact. These tools might finally provide definitive answers about what kinds of unknown life might persist in the Himalayas' most remote locations. Whether the evidence points to unknown animals, remnant human populations, or something else entirely, the Yeti mystery represents a fundamental question about the completeness of our knowledge, about what forms of life might adapt to extreme environments, about whether the Earth's most isolated places might still harbor secrets that challenge our understanding of evolution, survival, and the boundaries between legend and reality. As the climate shifted across millennia, human settlements in the Himalayas took on forms that transcended simple survival. Monasteries appeared on cliff tops that seem impossible to reach. Temples carved into rock faces that would challenge modern engineering. Cave complexes that extend deep into mountainsides with architectural precision that suggests advanced planning and execution. These sacred sites represent more than religious devotion. They demonstrate technical capabilities that mainstream history has yet to fully explain. The monastery at Tiger's Nest clings to a vertical cliff face in Bhutan, built in 1692 around caves that had been used for meditation centuries earlier. The construction required techniques for moving materials up near vertical slopes, for anchoring structures to rock faces, for creating stable foundations on surfaces that appear to offer no support. Traditional accounts describe these achievements as miracles, but they might represent forgotten engineering knowledge. In the Spiti Valley, the monastery of Dankar perches on a rocky spur that overlooks the confluence of ancient rivers. The structure appears to grow from the rock itself, walls that follow natural contours while maintaining architectural integrity. Chambers carved into solid stone with acoustics designed for meditation and chanting. The precision suggests understanding of geology and engineering that exceeds what wooden tools and human labor alone should accomplish. The cave temples of Mustang present even greater mysteries. Hidden in cliff faces accessible only through concealed pathways, these chambers contain murals depicting astronomical events with accuracy that challenges historical timelines. Star charts that show celestial positions from periods when such observations should have been impossible. Calendars that demonstrate mathematical sophistication beyond what regional cultures are credited with possessing. Archaeological evidence suggests that many Buddhist sites were built atop earlier sacred locations, foundations that predate known Buddhist presence in the region, stone arrangements that align with astronomical phenomena that Buddhist traditions do not specifically emphasize, construction techniques that differ from later Buddhist architectural styles. These layered histories suggest that the Himalayas have attracted spiritual communities for far longer than written records document. The Hemis Monastery in Ladakh preserves manuscripts that describe construction techniques using methods that seem to minimize human labor. Instructions for moving large stones using principles of leverage and balance that suggest advanced understanding of physics. Descriptions of tools and techniques that do not appear in other historical records. Accounts of building projects completed in timeframes that seem impossibly short given traditional construction methods. In remote valleys of Nepal, small temples appear in locations where no regular human habitation should be possible. Structures built with stone blocks fitted together with precision that requires no mortar. Foundations that remain stable despite centuries of seismic activity. Chambers are designed with internal spaces that create acoustic effects that enhance meditation and ritual practice. The sophistication suggests builders with knowledge of advanced architectural principles. The distribution pattern of these sacred sites raises questions about coordination and communication across vast distances. Temples and monasteries appear at locations that form geometric relationships with each other, alignments that span hundreds of miles while maintaining mathematical precision, positioning that creates sight lines between distant peaks and sacred locations, networks of sacred geography that suggest planned development rather than random placement. Local traditions describe construction methods that involved more than human labor alone. Stories of stones that moved by themselves, of builders who worked without leaving footprints, of structures that appeared overnight in locations where construction materials were not available. While these accounts may represent mythological interpretation of actual events, they consistently describe capabilities beyond conventional construction techniques. The preservation of these sacred sites suggests design for extreme longevity. Structures built to withstand conditions that would destroy conventional buildings. Materials selected for durability across geological timescales. Construction techniques that allow for thermal expansion and seismic movement without structural failure. The builders seem to understand that their work needed to survive challenges beyond normal architectural considerations. Some monasteries preserve traditions describing earlier sacred sites that were deliberately sealed or hidden. Chambers filled with sand and stone to prevent access. Entranceways were camouflaged beyond recognition. Sacred objects buried in locations marked only by oral tradition. These accounts suggest that the visible temples represent only a portion of the region's sacred architecture, that hidden chambers and sealed structures might await discovery throughout the Himalayas. As modern research techniques allow for non-invasive exploration of these sites, new mysteries emerge. Ground-penetrating radar reveals chamber systems that extend far beyond visible structures. Acoustic analysis identifies spaces that produce resonance patterns suggesting complex internal geometry. Thermal imaging detects heat signatures that indicate air circulation systems designed for climate control. These discoveries point toward architectural sophistication that challenges conventional understanding of historical building capabilities in extreme mountain environments. Meanwhile, across the highest peaks, ancient builders demonstrated knowledge of celestial mechanics that challenges conventional timelines of scientific development. Temple doorways framed specific stars at precise moments in their cycles. Stone monuments mark solstices and equinoxes with accuracy that rivals modern instruments. Observatory platforms positioned to track planetary movements across decades of observation. These alignments suggest understanding of astronomy that extends far beyond casual skywatching. The monastery at Hemis contains a collection of astronomical instruments crafted from materials not native to the region. Bronze alloys that demonstrate advanced metallurgy. Precision grinding techniques that create optical surfaces of remarkable quality. Mechanical components that suggest understanding of gear ratios and clockwork principles centuries before such technology appeared elsewhere. The instruments remain functional, still capable of calculations that match modern astronomical software. In the Spiti Valley, stone circles mark positions where specific stars appear at crucial moments in agricultural cycles. The arrangements demonstrate understanding that the apparent positions of stars change gradually over centuries due to precession. The builders positioned their markers to account for these shifts, creating observatories that remained accurate across time spans that exceed individual human lifetimes. Planning for astronomical accuracy across generations. The cave complex at Tashigang contains chambers aligned to capture sunlight at specific times throughout the year. The geometry creates natural calendars that mark planting seasons, harvest periods, and religious observances. But the precision extends beyond practical agricultural needs. The alignments track subtle variations in Earth's orbital mechanics, changes that require centuries of continuous observation to detect and longer periods to verify. Ancient texts preserved in Himalayan monasteries describe astronomical phenomena with accuracy that predates telescopic observation by centuries. Star catalogs that list celestial coordinates with precision matching modern measurements. Descriptions of planetary movements that demonstrate understanding of elliptical orbits. Calculations of eclipse patterns that extend thousands of years into the past and future. Knowledge that should have been impossible without technological assistance. The positioning of sacred sites across the Himalayan region reveals geometric relationships that span hundreds of miles while maintaining mathematical precision. Temples positioned to create sightlines between distant peaks. Monasteries placed at locations that form triangulations with astronomical accuracy. Sacred geography that suggests coordinated planning across geographical scales that challenge communication capabilities attributed to ancient cultures. Local traditions describe methods for astronomical observation that go beyond visual techniques. Practices involving acoustic phenomena that allegedly enhanced perception of celestial movements. Meditation techniques are said to increase sensitivity to planetary influences. Ritual practices timed to cosmic events with precision that suggests detailed understanding of astronomical cycles. Methods that might represent lost technologies for enhanced observation. The astronomical knowledge preserved in Himalayan traditions includes understanding of celestial mechanics that mainstream science developed only recently. Awareness of gravitational effects between planetary bodies. Recognition of how solar activity influences atmospheric conditions. Understanding of how astronomical cycles correlate with climate patterns across geological time scales. Sophisticated appreciation for connections between cosmic and terrestrial phenomena. Stone monuments throughout the region mark positions of stars that are invisible to naked eye observation from current locations due to atmospheric conditions and light pollution. But calculations show that these stars would have been visible during specific historical periods when atmospheric conditions were different. The builders positioned their markers based on observations that required understanding of how environmental changes affect astronomical visibility. The accuracy of Himalayan astronomical alignments exceeds what should be possible using traditional observation methods. The precision requires correction for atmospheric refraction, compensation for the effects of altitude on celestial observations, understanding of how local geography influences the apparent positions of celestial objects, technical knowledge that suggests advanced understanding of observational astronomy. Some alignments track astronomical phenomena that occur on timescales beyond individual human observation. Precession cycles that require thousands of years to complete. Planetary alignments that occur at intervals spanning centuries. Stellar movements that become apparent only through multi-generational observation projects. The builders planned for astronomical accuracy across time spans that challenge conventional understanding of ancient scientific capabilities. Modern research using satellite positioning and computer modeling has confirmed that many Himalayan astronomical alignments maintain precision that exceeds 1 degree of arc. Accuracy that approaches the limits of naked eye observation under ideal conditions. The consistency of this precision across multiple sites suggests standardized methods and shared knowledge systems that operated across vast geographical distances. Networks of astronomical knowledge that may have connected ancient observers throughout the highest places on Earth. But in the remote reaches of the Mustang region, explorers speak of a discovery that challenges conventional understanding of natural phenomena. The Valley of Mirrors, a location where polished rock surfaces create reflections that seem to show more than present reality. Climbers report seeing landscapes in the reflections that do not match their actual surroundings. Images of structures where no buildings exist. Scenes of human activity in valleys known to be uninhabited. The phenomenon first gained attention in 1987 when a geological survey team photographed reflections that appeared to show a complex settlement in the mirrored surfaces. Structures with architectural styles that did not match any known regional traditions. People wearing clothing that seemed to represent a different time period. Activities suggesting a level of civilization that contradicted the valley's reputation for isolation and harsh conditions. Local guides refused to camp in the valley overnight. They described the reflections as windows into other times. Past and future events playing out in surfaces that should simply show the surrounding landscape. Sherpa traditions speak of the valley as a place where time becomes visible, where patient observers can witness events from different eras by watching the polished, stone surfaces under specific lighting conditions. The geological composition of the valley's rock faces provides a partial explanation for the reflective properties. Mineral deposits containing high concentrations of mica and quartz create natural mirror surfaces when exposed to specific angles of sunlight. But the clarity and consistency of the reflections exceed what these minerals should produce under natural conditions. The surfaces appear to have been enhanced or modified to improve their reflective capabilities. Researchers attempting to study the phenomenon have encountered technical difficulties that seem beyond normal equipment failure. Cameras malfunction when pointed at specific reflective surfaces. Digital recording devices produce images that show static or distortion at crucial moments. Measurement instruments provide readings that contradict visual observations. Equipment failures that occur consistently in certain locations while functioning normally elsewhere. The timing of the phenomena follows patterns that suggest astronomical influences. The clearest reflections occur during specific moon phases. Certain times of day produce more vivid images than others. Seasonal variations affect the quality and content of what appears in the mirrored surfaces. The correlation with celestial events suggests that the phenomena depend on factors beyond simple geology and lighting. Witnesses describe reflections that appear to respond to observer attention. Images that become clearer when viewed with peripheral vision, but fade under direct observation. Scenes that seem to acknowledge the presence of watchers by including figures that appear to look back at the observers. Interactive elements that suggest the reflections involve more than passive recording of past or alternative events. The content of the reflected images provides tantalizing glimpses of what might be hidden elsewhere in the Himalayas. Architectural details that match descriptions from oral traditions about lost civilizations. Tool designs that exceed known regional technology. Agricultural techniques adapted to high-altitude conditions that modern farming has not developed. Cultural practices that combine elements from different known traditions in unique ways. Documentation efforts have produced inconclusive results. Photographs sometimes capture anomalous reflections, but often show only normal geological formations. Video recordings occasionally preserve segments that clearly show unusual phenomena, but more frequently document ordinary rock surfaces. The inconsistency suggests that the phenomena occur under specific conditions that are difficult to predict or control. Scientific analysis of the rock surfaces has revealed trace elements not typically found in regional geology. Metallic inclusions that could enhance reflective properties. Crystal formations that might create optical effects under specific conditions. Geological anomalies that could explain enhanced mirror qualities, but do not account for the complex content of the reflected images. The Valley of Mirrors represents a category of Himalayan mysteries that blend natural phenomena with unexplained observations. Locations where environmental conditions create experiences that challenge conventional understanding of perception and reality. Places where the boundary between physical and metaphysical becomes unclear. Where natural processes might preserve or reveal information in ways that mainstream science has yet to recognize or explain. Whether the valley's phenomena represent advanced optical illusions, unknown geological processes, or something beyond current scientific categories, it serves as a reminder that the Himalayas continue to present mysteries that defy easy explanation. That in the world's most extreme environments, normal rules might not apply. That reality itself might follow different patterns in places where the Earth reaches toward the sky and touches realms beyond ordinary human experience. As the planet's climate continues its ancient dance of warming and cooling, the glaciers of the Himalayas serve as frozen archives that preserve evidence across millennia. These moving rivers of ice act as natural time machines, capturing and preserving organic materials, atmospheric gases, and physical evidence from periods when the world was dramatically different from today. But recent discoveries suggest that glacial ice might preserve more than just climate data. It might hold traces of human activity from times when these high valleys enjoyed more temperate conditions. The ice cores extracted from Himalayan glaciers contain layers that tell stories of atmospheric composition stretching back hundreds of thousands of years. Each annual layer preserves a sample of the air that existed during specific time periods. Volcanic ash from eruptions that darkened skies across continents. Pollen from plants that grew during different climate periods. Dust from desert expansions and contractions. Atmospheric chemistry that reveals the state of the ancient world. But trapped within these frozen layers, researchers have discovered anomalies that suggest human presence during periods much earlier than conventional timelines propose. Charcoal particles indicating fire use at altitudes and time periods when human habitation should have been impossible. Microscopic fragments of worked metal that appear to predate known metallurgy in the region. Organic compounds that suggest agricultural activity during climate periods when plant cultivation at high altitudes should not have been feasible. The preservation conditions within glacial ice create perfect environments for maintaining organic materials across geological time scales. Materials that would decay within decades at lower altitudes can persist for millennia when frozen in glacial environments. DNA samples remain intact. Protein structures maintain their organization. Even cellular structures can survive in recognizable form when properly preserved in ice. Recent glacial retreats have exposed surfaces that have been frozen for thousands of years. Objects and structures emerge from melting ice, like artifacts from a natural museum. Wooden tools crafted from tree species that no longer grow at these altitudes. Textile fragments woven from fibers that require agricultural techniques adapted to high-altitude conditions. Architectural elements that suggest permanent structures rather than temporary shelters. The dating of materials emerging from glacial ice challenges conventional understanding of when human adaptation to high-altitude environments occurred. Radiocarbon analysis indicates human presence during climate periods when the Himalayas should have been even more hostile to settlement than they are today. Tool technologies that appear more sophisticated than what survival conditions should have allowed. Evidence of long-term habitation rather than occasional hunting or trading expeditions. Glacial movement patterns create natural conveyor systems that transport materials across vast distances while maintaining preservation conditions. Objects deposited in high alpine zones can be carried downslope over centuries or millennia while remaining frozen and protected. This transportation system could preserve evidence of human activity from locations that are now completely inaccessible or buried beneath permanent ice fields. The chemical composition of glacial ice reveals information about ancient atmospheric conditions that indirectly documents human activity. Smoke particles from large-scale fires that suggest controlled burning practices. Metalworking residues that indicate smelting operations at times and locations not documented by conventional archaeology. Agricultural pollen in concentrations that suggest extensive farming rather than scattered wild plant growth. Climate models indicate that the Himalayas experienced periods of relative warmth that could have supported human habitation at altitudes that are currently too hostile for permanent settlement. During these warmer periods, tree lines would have been higher, water sources are more abundant, weather patterns are more stable, conditions that could have allowed sophisticated civilizations to develop at elevations where only the hardiest explorers venture today. The rate of current glacial retreat creates both opportunities and challenges for researchers studying these frozen archives. Melting exposes new evidence, but also threatens to destroy materials before they can be properly studied. Organic materials that have been preserved in ice for millennia can decompose within days when exposed to atmospheric conditions, creating a race against time to document and preserve evidence as it emerges. Advanced analysis techniques allow researchers to extract information from glacial samples that would have been impossible to detect using earlier methods. DNA sequencing can identify species presence from microscopic fragments. Mass spectrometry can detect trace chemicals that indicate specific human activities. Microscopic analysis can identify work materials that suggest technological capabilities beyond simple tool use. The implications of human-related materials in ancient glacial ice extend beyond simple questions of historical timeline. They suggest that human adaptation to extreme environments might have followed different pathways than mainstream archaeology proposes. That technical knowledge for surviving at high altitudes might be older and more sophisticated than currently understood. That the relationship between climate change and human civilization might follow patterns that have not yet been recognized. As glacial retreat accelerates, the window for studying these frozen archives narrows. Each season brings new exposures, but also destroys evidence that has waited millennia for discovery. The Himalayan glaciers represent libraries of Earth's history that are simultaneously opening and burning, revealing secrets that challenge our understanding of human capability and environmental adaptation, while threatening to destroy the very evidence that could rewrite the story of how our ancestors mastered the highest places on Earth. These proposals challenge conventional timelines by proposing that mountain environments offer advantages that offset their obvious difficulties. Natural fortification, protection from coastal flooding, access to mineral resources, climate stability during periods of global upheaval, conditions that could have attracted advanced civilizations seeking refuge from catastrophic events in lower elevations. The conventional narrative describes human migration into the Himalayas as a gradual process driven by population, pressure, and resource competition in more hospitable environments. Mountain settlement represents adaptation to harsh conditions rather than preference for highland life. But alternative interpretations suggest that some ancient peoples might have chosen high-altitude environments for strategic reasons, seeking isolation to preserve knowledge, avoiding contact with civilizations that they considered destructive or corrupting. Genetic studies of modern Himalayan populations reveal ancestry patterns that suggest more complex migration histories than simple gradual mountain adaptation. DNA analysis indicates multiple waves of human settlement with different origins and timeframes. Some genetic markers suggest ancestry from populations that have no clear geographical origin in the archaeological record. Lineages that appear suddenly in mountain communities without clear migration pathways from surrounding lowland regions. The linguistic diversity of Himalayan regions preserves elements that do not align with conventional theories of language development and transmission. Isolated dialects contain vocabulary and grammatical structures that appear more ancient than the overall language families to which they belong. Root words that suggest technical knowledge of metallurgy, astronomy, and engineering that predates known development of such technologies in the region. Archaeological evidence from high-altitude sites sometimes reveals technological sophistication that exceeds what survival conditions should have allowed. Tool assemblages that include specialized implements for tasks beyond basic subsistence. Architectural remains that suggest permanent settlements rather than seasonal camps. Artistic traditions that indicate leisure time and cultural development beyond what marginal environments typically support. Some researchers propose that ancient Himalayan civilizations might have developed in response to global catastrophes that made lowland areas uninhabitable for extended periods. Volcanic winters caused by massive eruptions. Climate shifts that altered growing seasons. Sea level changes that eliminated coastal settlements. Under such conditions, mountain environments might have offered the most stable long-term survival prospects for advanced societies. Alternative theories suggest that Himalayan peoples might have maintained contact with distant civilizations through trade and communication networks that left minimal archaeological trace. Exchange systems based on lightweight, high-value goods that would not survive in the archaeological record. Knowledge transmission through oral traditions and memory techniques that preserved technical information without written documents. Cultural connections that spanned continents without creating the typical evidence of regular commerce. The preservation of advanced astronomical knowledge in Himalayan traditions could indicate inheritance from earlier civilizations with sophisticated scientific capabilities. Mathematical concepts that appear too complex for the social structures that supposedly developed them. Observational techniques that require multi-generational coordination and institutional stability. Scientific knowledge that suggests educational institutions and professional astronomer classes that do not appear in conventional historical reconstructions. Certain technological traditions in Himalayan regions demonstrate capabilities that seem inconsistent with available materials and energy sources. Metallurgy techniques that produce alloys requiring smelting temperatures are difficult to achieve with available fuels. Construction methods that move and position stones weighing many tons without mechanical advantages, visible in the archaeological record. Engineering solutions that suggest understanding of physics, principles beyond what educational systems should have been able to transmit. The geographic distribution of advanced Himalayan sites suggests coordination and planning across distances that challenge conventional understanding of ancient communication capabilities. Settlements positioned to maintain visual contact across mountain ranges. Construction projects that seem synchronized despite separation by hundreds of miles. Cultural similarities that span regions with no apparent regular contact through normal travel routes. Some alternative theories propose extraterrestrial contact as an explanation for advanced capabilities in ancient Himalayan civilizations. The high altitude and isolation of mountain environments would provide ideal conditions for contact with beings seeking to avoid detection by larger human populations. The technical knowledge preserved in Himalayan traditions might represent instruction from advanced non-human intelligences. Archaeological anomalies could indicate technological assistance beyond human capabilities of the relevant time periods. Whether alternative theories prove accurate or not, they serve to highlight gaps in conventional understanding of ancient Himalayan societies. The mountain regions clearly supported human populations with capabilities that challenge simple narratives of gradual technological development and environmental adaptation. The preservation of advanced knowledge in isolated communities suggests cultural continuity across time periods that mainstream archaeology has difficulty explaining. Making the Himalayas a laboratory for testing assumptions about human capability, technological development, and the relationship between environment and civilization. Where alternative histories might prove as revealing as conventional archaeology in understanding what forms of human society the highest places on Earth have actually supported across deep time. Deep within the cliff faces of the Mustang region, a network of caves reveals mysteries that challenge conventional understanding of ancient human capabilities and preservation. These chambers, carved into nearly vertical rock walls, contain artifacts and artwork that suggest occupancy by peoples with sophisticated knowledge and artistic traditions. Yet access to these caves requires technical climbing skills that seem beyond the capabilities attributed to ancient populations. The caves themselves represent a puzzle that combines engineering achievement with cultural sophistication in ways that conventional archaeology struggles to explain. The caves exist at elevations that make casual visitation impossible, carved into cliff faces that rise hundreds of feet above valley floors with no apparent access routes from ground level. Modern rock climbers equipped with advanced gear find these locations challenging to reach. Yet the caves show evidence of regular occupancy over extended periods. Living spaces equipped with storage areas, cooking facilities, and spaces designed for community activities. The infrastructure suggests permanent or semi-permanent habitation rather than emergency shelter. Inside the caves, murals cover walls and ceilings with artwork that demonstrates sophisticated artistic traditions. The paintings depict astronomical events with accuracy that indicates advanced observational capabilities. Star charts showing celestial configurations that require decades of observation to verify. Calendars that track multiple astronomical cycles simultaneously. Mathematical diagrams that suggest understanding of geometric principles beyond basic measurement and construction needs. The preservation conditions within the caves have maintained organic materials that normally decay within decades. Textiles woven with techniques that demonstrate advanced understanding of fiber preparation and loom operation. Wooden implements crafted with precision that indicate specialized tool-making capabilities. Paper documents written in scripts that combine elements from multiple known writing systems while including symbols that appear to represent technical or scientific concepts. Archaeological analysis of the cave contents reveals occupancy patterns that span centuries with periods of abandonment and reoccupancy. Material layers that suggest different cultural groups use the same spaces across extended time periods. Artifact assemblages that include items from distant geographical regions alongside locally produced goods. Evidence of trade connections or cultural exchange that required transportation across difficult mountain terrain. The construction techniques used to create the caves demonstrate engineering knowledge that exceeds what simple hand tools should accomplish. Chamber walls carved with precision that maintain structural integrity despite the surrounding rock's natural fracture patterns. Ventilation systems that create air circulation in spaces that would otherwise become unlivable. Water collection and storage systems that capture and preserve moisture in an extremely arid environment. Some caves contain libraries of manuscripts written on materials that suggest advanced preparation techniques. Palm leaf documents that require chemical treatment to achieve the durability necessary for long-term preservation. Metal plates inscribed with texts using engraving techniques that produce letter forms of remarkable precision. Storage systems designed to protect written materials from moisture, temperature fluctuations, and pest damage across centuries of changing conditions. The distribution pattern of the caves suggests coordinated planning rather than random selection of suitable sites. Chambers are positioned to provide visual communication between different cave complexes. Locations chosen to optimize access to water sources while maintaining defensive advantages. Spacing that creates a network of interconnected refuges across the entire cliff system. Strategic thinking that indicates organized communities rather than individual hermits seeking isolation. Local traditions describe the caves as repositories of ancient knowledge maintained by guardian communities. Oral histories speak of peoples who withdrew from lowland areas during periods of conflict or environmental catastrophe. Groups who chose isolation to preserve cultural and technical knowledge for future generations. Communities that maintained the caves as libraries and educational centers for specialized knowledge that required protection from outside interference. Modern exploration of the cave network continues to reveal new chambers and passages. Ground-penetrating radar indicates the existence of sealed spaces that may contain additional artifacts or artwork. Acoustic analysis suggests that some caves are connected by tunnel systems that are not visible from current access points. Thermal imaging detects air circulation patterns that indicate hidden chambers or passages that have not yet been explored. The mystery of the Mustang Caves extends beyond questions of construction and occupancy to fundamental issues about ancient human capabilities and motivations. The caves represent achievements that require coordination between specialized skills: rock carving, artistic production, manuscript preparation, astronomical observation, and community organization. The combination suggests societies with educational institutions and professional specializations that conventional archaeology does not typically associate with ancient mountain populations. As exploration technology advances, the caves of Mustang may provide answers to questions about the sophistication of ancient Himalayan civilizations. The preserved materials offer direct evidence of technical capabilities, cultural practices, and knowledge systems that oral traditions have maintained, but physical evidence has rarely substantiated, making these hidden chambers potential keys to understanding whether the Himalayas have indeed preserved secrets of human achievement that challenge conventional timelines of technological and cultural development in the world's most extreme environments. As the climate shifted across geological time, the peoples of the Himalayas developed sophisticated systems for preserving knowledge that transcended the limitations of written records. Their myths function as libraries encoded in story form, technical information disguised as folklore, historical records preserved as religious traditions, memory techniques that could maintain accuracy across centuries of oral transmission. These narrative systems suggest that ancient mountain peoples possessed methods for preserving and transmitting knowledge that modern societies have lost or forgotten. The Tibetan tradition of Terma represents a systematic approach to hiding and recovering important information. Sacred texts and artifacts deliberately concealed during periods of danger. Knowledge preserved in locations known only to initiated practitioners. Recovery methods that depend on specific individuals appearing at predetermined times to retrieve hidden materials. The system demonstrates planning for knowledge preservation across time spans that exceed individual lifetimes. Institutional thinking that prioritizes cultural continuity over immediate access to information. Sherpa creation myths contain surprisingly specific geographical details about landscape features that require geological knowledge to verify. Stories describe the formation of mountain peaks through processes that align with modern understanding of tectonic activity. Flood narratives that correspond to periods of glacial lake outburst flooding documented by geological evidence. Migration stories that follow routes through mountain passes that climate reconstructions show were only open during specific historical periods. The oral traditions preserve technical information disguised as mythological narratives. Stories about magical tools that function according to principles recognizable as mechanical engineering. Tales of supernatural abilities that describe techniques for navigation, weather prediction, and high-altitude survival. Religious practices that encode instructions for metallurgy, agriculture, and construction using symbolic language that conceals practical knowledge within spiritual teaching. Memory palace techniques developed by Himalayan practitioners demonstrate cognitive capabilities that exceed typical human performance. Methods for organizing and retrieving vast amounts of information using spatial and narrative associations. Techniques that allow individuals to memorize entire libraries of texts with accuracy that rivals written documentation. Systems that can preserve technical knowledge across generations without degradation through normal human memory limitations. The consistency of certain mythological elements across different Himalayan cultures suggests shared historical experiences rather than independent folklore development. Multiple societies describe similar cosmic catastrophes, cultural migrations, and technological achievements using different symbolic systems, but consistent underlying narratives. Cross-cultural verification that indicates the stories preserve memories of actual events rather than purely imaginative creation. Mathematical concepts embedded in traditional songs and ceremonies demonstrate sophisticated understanding of numerical relationships and geometric principles. Ritual dances that trace patterns corresponding to astronomical calculations. Musical compositions that encode mathematical ratios used in architectural construction. Ceremonial practices that preserve engineering formulas within religious activities. Knowledge preservation systems that maintain technical accuracy while disguising the information as cultural expression. The seasonal cycles of storytelling in Himalayan communities create educational systems that transmit different categories of knowledge at appropriate times. Winter narratives that preserve historical and genealogical information during periods of indoor gathering. Summer stories that encode geographical and navigational knowledge shared during travel seasons. Seasonal timing that ensures knowledge transmission occurs when it is most relevant and likely to be retained. Local legends describe methods for enhancing human memory and perception that go beyond normal cognitive capabilities. Meditation practices are said to increase information retention and recall accuracy. Dietary techniques that allegedly improve mental clarity and learning ability. Environmental conditions in high-altitude locations that supposedly enhance cognitive function. Practices that might represent genuine techniques for optimizing human information processing capabilities. The integration of astronomical knowledge into mythological narratives serves multiple functions beyond simple calendar keeping. Stories that preserve observations of long-term celestial cycles spanning centuries or millennia. Myths that encode predictions about future astronomical events based on pattern recognition across extended time periods. Some mythological traditions describe communication methods that transcend normal human limitations. Stories about telepathic contact between distant communities. Legends of message systems that operate faster than physical travel should allow. Narratives that might encode descriptions of communication technologies that leave no archaeological trace. Preservation of knowledge about coordination systems that enabled planning and cooperation across vast geographical distances. The psychological techniques embedded in mythological transmission create reinforcement systems that enhance memory retention and accuracy. Emotional associations that make information more memorable and resistant to distortion. Narrative structures that provide multiple retrieval pathways for the same information. Symbolic systems that create redundant encoding of critical knowledge. Methods that demonstrate sophisticated understanding of cognitive psychology and information theory. Modern research into memory and consciousness suggests that human cognitive capabilities might exceed conventional limitations under specific conditions. Studies of exceptional memory performance in traditional societies show abilities that challenge assumptions about normal human information processing. Research into altered states of consciousness indicates that meditation and other practices can enhance memory formation and retrieval. Scientific validation of techniques that ancient peoples might have developed to optimize knowledge preservation and transmission. The mythological traditions of the Himalayas represent more than folklore entertainment or religious instruction. They constitute sophisticated information management systems designed to preserve essential knowledge across unpredictable time periods and changing social conditions. Libraries that exist in human memory rather than physical storage. Educational institutions that operate through cultural transmission rather than formal schooling, making these narrative traditions potential keys to understanding how ancient societies maintain technical and historical knowledge without depending on written records that could be lost or destroyed during periods of social upheaval or environmental catastrophe. Meanwhile, in libraries and archives scattered across the world, cartographers have documented geographical features in the Himalayan region that do not align with modern topographical surveys. These ancient maps show mountain ranges, valleys, and water features and configurations that sometimes contradict current landscape reality. Rivers flowing in directions that modern geography cannot confirm. Settlements marked in locations where no archaeological evidence suggests human habitation. Geographical details that seem to describe the Himalayas during different climate periods or from perspectives that conventional mapmaking should not have been able to achieve. The Piri Reis map of 1513 includes details of continental coastlines that were supposedly unknown to European cartographers of that period. But less attention has been paid to its representation of mountain regions that show internal geographical features with accuracy that exceeds what exploration and surveying capabilities of the time should have accomplished. Mountain passes marked with precision that suggests direct knowledge rather than speculation. Elevation changes, indicated through techniques that demonstrate understanding of topographical representation beyond normal medieval cartographic capabilities. Chinese maps from the Tang Dynasty period describe Himalayan regions with geographical details that indicate knowledge of areas not officially explored until centuries later. Trade route documentation that shows paths through mountain regions that modern surveys confirm are optimal for navigation, despite extreme difficulty. Settlement locations that align with water sources and climate conditions that require detailed geographical knowledge to identify. Mapping accuracy that suggests systematic exploration and survey work beyond what historical records document. Tibetan monastery collections preserve maps drawn on materials and using techniques that suggest great antiquity. Geographical representations that show the Himalayan region during periods when glacial extent was different from current conditions. Valley systems that would have been accessible during warmer climate periods, but are now blocked by permanent ice. Landscape features that align with geological reconstructions of ancient climate conditions rather than contemporary geography. The accuracy of elevation representation in some ancient maps exceeds what should have been possible without modern surveying instruments. Topographical details that demonstrate understanding of mathematical relationships between altitude, atmospheric pressure, and visual perspective. Techniques for representing three-dimensional landscape features on flat surfaces using projection methods that require sophisticated geometric knowledge. Cartographic capabilities that challenge conventional understanding of ancient technical abilities. Some maps include annotations and scripts that combine elements from multiple known writing systems while including symbols that appear to represent technical or navigational concepts. Notation systems that suggest professional cartographic traditions with specialized vocabulary for geographical description. Technical terminology that indicates institutional knowledge and training rather than informal exploration records. Evidence of systematic geographical science rather than casual travel documentation. The distribution patterns of geographical knowledge preserved in ancient maps suggests communication networks that spanned continental distances. Similar cartographic techniques appearing in maps produced by cultures with no apparent direct contact. Geographical details about remote regions appearing in maps created by societies with no documented exploration capabilities in those areas. Knowledge transmission that indicates trade or communication systems beyond what historical records typically document. Certain ancient maps show geographical features that modern satellite surveys have confirmed, but that ground-based exploration had not discovered when the maps were supposedly created. Hidden valleys that are only visible from aerial perspectives. Water sources that require specialized knowledge to locate. Geographical relationships that become apparent only when viewed from elevations that ancient peoples should not have been able to achieve. The preservation of these maps in scattered locations suggests deliberate distribution of geographical knowledge for strategic or educational purposes. Copies of similar maps appearing in libraries separated by thousands of miles. Geographical information preserved in multiple cultural and linguistic contexts. Distribution patterns that indicate systematic knowledge sharing rather than random preservation of travel records. Analysis of map-making materials and techniques reveals capabilities that challenge conventional understanding of ancient technology. Ink formulations that remain stable across centuries without fading or chemical degradation. Paper preparation techniques that create durability exceeding modern archival standards. Drawing instruments that produce precision exceeding what simple tools should accomplish. Technical capabilities that suggest specialized industries supporting cartographic production. Modern comparison of ancient geographical representations with satellite imagery and geological surveys reveals correlations that are difficult to explain through conventional exploration methods. Ancient maps showing geographical features that are only visible during specific seasonal or weather conditions. Representations that align with geological structures not apparent from ground-level observation. Accuracy that suggests observation methods beyond normal human visual capabilities. Some researchers propose that ancient cartographers might have had access to aerial observation, capabilities that have not been preserved in the historical record. Flight technologies using principles that would not leave archaeological traces. Observation techniques that enhanced visual range beyond normal human limitations. Knowledge transmission systems that preserved geographical information from sources that are no longer available to modern investigation. The implications of accurate ancient geographical knowledge extend beyond simple questions of exploration. Capability to fundamental issues about ancient scientific and technical achievements. The maps suggest systematic geographical research programs that required institutional support and professional expertise. Educational systems that could train cartographers in advanced mathematical and observational techniques. Social organizations capable of coordinating exploration and knowledge preservation across vast geographical areas in extended time periods. Whether these cartographic mysteries indicate advanced ancient civilizations, unknown exploration techniques, or alternative methods of geographical knowledge acquisition, they challenge conventional understanding of what ancient peoples knew about the world's most inaccessible regions, making the ancient maps potential evidence that the Himalayas have been studied and documented by observers with capabilities that mainstream archaeology has yet to recognize or explain. But among the monasteries scattered across the high Himalayas, one legend persists about a monk whose astronomical observations challenged the knowledge systems of his time. Tenzin Norbu lived in a remote monastery in the Spiti Valley during the 8th century. According to preserved accounts, he developed techniques for celestial observation that produced mathematical calculations centuries ahead of their time. His predictions of astronomical events demonstrated accuracy that monastery records preserved and verified across decades of continued observation. The monastery chronicles describe Tenzin Norbu as possessing knowledge that he claimed came from ancient texts hidden in sealed chambers beneath the monastery foundations. Documents written in scripts that none of his contemporaries could read. Mathematical formulas using numerical systems that exceeded the calculation methods available during his lifetime. Astronomical data that described celestial mechanics with precision that should have required telescopic observation to verify. Tenzin Norbu's calculations predicted solar eclipses visible from Himalayan locations with accuracy that monastery records confirmed across his lifetime and beyond. His eclipse predictions remained accurate for decades after his death. Calendar calculations that accounted for leap years and seasonal variations using mathematical techniques that medieval astronomy had not yet developed. The monk's astronomical observations included detailed records of planetary movements that required understanding of elliptical orbits and gravitational mechanics. He predicted the positions of Venus and Mars with accuracy that impressed visiting scholars from distant regions. Mathematical models that described planetary motion using geometric principles that aligned with later discoveries by European astronomers. Knowledge that suggested access to observational data spanning centuries of systematic skywatching. Local traditions describe Tenzin Norbu as using meditation techniques that allegedly enhanced his ability to perceive celestial phenomena, practices that supposedly allowed him to detect stellar movements invisible to normal observation. Methods for mental calculation that enabled complex mathematical operations without written notation. Cognitive techniques that might represent advanced methods for optimizing human observational and computational capabilities. The monastery preserved instruments that Tenzin Norbu allegedly constructed for astronomical observation. Bronze devices with precision gear mechanisms that demonstrate advanced understanding of metallurgy and mechanical engineering. Optical components ground to specifications that create magnification effects exceeding what traditional techniques should accomplish. Construction methods that produce durability spanning centuries while maintaining calibration accuracy. Written records describe Tenzin Norbu collaboration with other monks in creating observational programs that continued beyond individual lifetimes. Systematic sky-watching schedules that tracked celestial events across decades. Record-keeping methods that preserved observational data with accuracy that allowed future verification of predictions. Institutional approaches to scientific observation that suggest educational systems for training professional astronomers. The monks' geographical knowledge exceeded what regional exploration should have provided. He described relationships between celestial events and geographical phenomena that demonstrated understanding of how astronomical cycles affect climate patterns. Knowledge of distant mountain ranges and their astronomical visibility from different locations. Geographic information that suggested travel or communication networks spanning vast distances across difficult terrain. Tenzin Norbu's influence extended beyond his immediate monastery to visiting scholars who carried his methods to other regions. Astronomical techniques that appeared in distant locations after contact with monks trained in his methods. Mathematical knowledge that spread through scholarly networks connecting institutions across Central Asia. Educational influence that suggests his innovations were recognized and adopted by contemporary astronomical practitioners. The preservation of Tenzin Norbu's work in monastery archives provides rare documentation of individual scientific achievement in ancient Himalayan contexts. His mathematical formulas remain comprehensible using modern astronomical software. His predictions can be verified through computer modeling of historical celestial events. His observational techniques demonstrate systematic approaches to scientific investigation that challenge assumptions about medieval scientific capabilities. Modern analysis of Tenzin Norbu's astronomical records reveals knowledge that anticipates discoveries made centuries later by European science. Understanding of precession cycles that require multi-generational observation projects to detect. Awareness of gravitational influences between celestial bodies that medieval physics had not yet recognized. Mathematical sophistication that suggests educational systems capable of transmitting advanced scientific knowledge across generations. The mystery of Tenzin Norbu's knowledge sources remains unsolved. The ancient texts he claimed to study have never been found or independently verified. The techniques he developed for enhanced observation cannot be replicated using documented methods. His mathematical knowledge appears to exceed what educational opportunities of his time and place should have provided, making him a representative figure for the broader mysteries of scientific knowledge preservation in ancient Himalayan contexts. Whether Tenzin Norbu's achievements represent individual genius, access to lost ancient knowledge, or techniques for cognitive enhancement that have been forgotten, his legend illustrates the sophisticated intellectual traditions that flourished in Himalayan monasteries. His story suggests that the mountains served not only as refuges for spiritual practice, but as centers for scientific observation and mathematical research, where individual practitioners might achieve understanding of cosmic phenomena that challenged the knowledge systems of their time and anticipated discoveries that mainstream science would not make for centuries to come. As erosion and weathering continue their slow work across millennia, they reveal rock formations in the Himalayas that challenge conventional understanding of geological processes and natural stone formation. Monoliths that appear to have been shaped by forces more precise than normal weathering patterns. Cave systems with geometries that suggest artificial excavation rather than natural water erosion. Stone arrangements that maintain mathematical relationships, despite being subjected to seismic activity and climate changes that should have disrupted any original positioning. The megalithic structures scattered throughout the Himalayan region display construction techniques that exceed what should be possible using the tools and methods attributed to ancient peoples. Stone blocks weighing multiple tons are positioned with precision that requires understanding of leverage, transportation, and engineering principles. Joints between stones fitted so precisely that gaps are nearly invisible despite centuries of thermal expansion and seismic movement. Construction quality that exceeds many modern building standards for durability and precision. Geological surveys have identified stone compositions in ancient structures that do not match local bedrock formations. Building materials, quarried from sources hundreds of miles away and transported across mountain terrain that challenges modern heavy equipment. Rock types selected for specific structural properties that demonstrate advanced understanding of material science and engineering applications. Stone selection that suggests geological knowledge and resource management capabilities beyond subsistence-level technology. Cave systems throughout the Himalayas exhibit geometric properties that appear too regular to result from natural water erosion alone. Chambers with circular or rectangular cross-sections that maintain consistent dimensions across extended lengths. Tunnel networks that follow straight paths through solid rock despite changes in geological composition. Acoustic properties that suggest deliberate design for sound enhancement and communication purposes. The positioning of many megalithic sites demonstrates awareness of geological stability that requires understanding of seismic patterns and bedrock composition. Ancient builders selected locations that have remained stable despite centuries of earthquake activity. Foundation techniques that distribute structural loads in ways that prevent damage from ground movement. Site selection that suggests geological surveying capabilities and long-term planning for structural permanence. Some stone formations display evidence of heat treatment or chemical processing that alters rock properties beyond what natural geological processes typically produce. Surface modifications that increase hardness and weather resistance. Color changes that indicate exposure to temperatures exceeding what normal fires should achieve. Chemical compositions that suggest treatment with substances not available from local environmental sources. The tool marks preserved on ancient stonework demonstrate cutting and shaping techniques that challenge understanding of available technology. Precision tooling that produces smooth, regular surfaces on extremely hard rock types. Cutting patterns that suggest powered tools rather than manual stoneworking. Finish quality that exceeds what Bronze or Iron Age technology should accomplish on materials like granite and quartzite. Astronomical alignments built into megalithic structures require understanding of both geological engineering and mathematical astronomy. Stone monuments are positioned to track celestial events while maintaining structural stability across geological timescales. Alignment precision that accounts for precession and other long-term astronomical changes. Integration of architectural and astronomical knowledge that suggests advanced educational systems and professional specialization. The distribution patterns of megalithic sites across the Himalayan region indicate coordinated planning and construction projects spanning vast geographical areas. Similar architectural techniques appear in locations separated by hundreds of miles. Construction quality and materials that suggest shared technological knowledge and resource management systems. Site relationships that form geometric patterns when viewed from aerial perspectives. Underground chamber systems carved into bedrock demonstrate excavation capabilities that exceed what manual labor using primitive tools should accomplish. Subterranean spaces with complex geometries that require understanding of structural engineering and ventilation systems. Excavation techniques that remove massive quantities of stone whilst maintaining ceiling stability and preventing structural collapse. Underground architecture that suggests specialized knowledge of geology and engineering. Certain geological features appear to have been artificially modified to enhance their natural properties. Rock formations that have been shaped to improve acoustic characteristics or water collection capabilities. Natural caves that show evidence of deliberate expansion and architectural modification. Landscape features that appear to have been engineered to serve specific functions while maintaining the appearance of natural formation. The preservation of artificial geological modifications across millennia demonstrates construction techniques designed for extreme longevity. Engineering approaches that account for weathering, seismic activity, and climate changes across geological timescales. Materials science that selects and treats stone for maximum durability under extreme environmental conditions. Construction planning that prioritizes permanence over short-term convenience or cost efficiency. Modern geological analysis using advanced sensing techniques reveals anomalies in rock formations that suggest artificial modification beyond what visual inspection can detect. Ground-penetrating radar identifies voids and structural patterns that indicate artificial construction within apparently natural rock formations. Magnetic surveys detect metal inclusions and compositional anomalies that suggest technological intervention in geological processes. Thermal imaging reveals heat distribution patterns that indicate artificial chambers and passages within solid rock formations. The geological anomalies of the Himalayas raise fundamental questions about ancient human capabilities and the relationship between technology and environment in extreme conditions. The evidence suggests engineering knowledge and construction capabilities that challenge conventional timelines of technological development. Whether these anomalies represent advanced ancient civilizations, unknown geological processes, or alternative approaches to construction and engineering, they indicate that the Himalayas preserve evidence of human achievement that mainstream archaeology has yet to fully recognize or explain. But in the isolated valleys, where medicinal plants grow at altitudes that challenge human survival, ancient healers developed therapeutic knowledge that modern pharmacology has barely begun to understand. Himalayan traditional medicine preserves formulations that demonstrate sophisticated understanding of plant chemistry, human physiology, and therapeutic techniques that exceed what subsistence-level societies typically develop. Monastery libraries contain medical texts describing surgical procedures, diagnostic methods, and pharmaceutical preparations that suggest educational systems for training professional healers with capabilities that challenge conventional understanding of ancient medical knowledge. The traditional Tibetan medical system, Soa Rigpa, includes diagnostic techniques that demonstrate understanding of human anatomy and physiological processes centuries ahead of mainstream medical development. Pulse diagnosis methods that claim to detect internal organ conditions through subtle variations in blood flow patterns. Urine analysis techniques that allegedly identify specific diseases through color, consistency, and chemical properties observable without laboratory equipment. Diagnostic capabilities that suggest knowledge of human biology beyond what dissection and observation alone should provide. Medicinal plant preparations used in Himalayan healing traditions demonstrate advanced understanding of pharmaceutical chemistry and drug interactions. Herbal formulations that combine multiple active compounds in ratios that optimize therapeutic effects while minimizing side effects. Processing techniques that enhance bioavailability and stability of plant-based medications. Knowledge of drug synergies and antagonistic interactions that requires understanding of molecular-level pharmaceutical processes. The preservation methods used for medicinal materials in extreme mountain environments show sophisticated understanding of chemistry and storage techniques. Methods for maintaining potency of organic compounds across seasons and years without refrigeration or chemical preservatives. Preparation techniques that concentrate active ingredients while removing harmful substances. Storage systems that protect medications from degradation due to temperature fluctuations, humidity changes, and atmospheric pressure variations at high altitudes. Ancient medical texts preserved in Himalayan monasteries describe surgical procedures that demonstrate anatomical knowledge and technical skills exceeding what medieval medicine should have accomplished. Descriptions of cataract surgery using techniques that anticipate modern ophthalmological procedures. Brain surgery methods that show understanding of neurological anatomy and surgical precision. Medical procedures that suggest access to anesthetics and antiseptic techniques not documented in mainstream medical history. The integration of astronomical knowledge into medical practice demonstrates understanding of biological rhythms and environmental influences on human health. Therapeutic techniques timed to lunar cycles and seasonal changes. Diagnostic methods that account for altitude, atmospheric pressure, and cosmic radiation effects on human physiology. Medical approaches that recognize connections between celestial phenomena and biological processes. Centuries before modern chronobiology emerged as a scientific discipline. Alchemical traditions preserved in Himalayan monasteries describe methods for creating medicinal substances, using techniques that suggest advanced understanding of chemistry and materials science. Descriptions of metallic preparations that require sophisticated knowledge of metallurgy and chemical processing. Instructions for creating pharmaceutical compounds, using minerals and metals in combinations that demonstrate understanding of chemical reactions and therapeutic applications. The geographical distribution of medicinal knowledge across Himalayan regions indicates communication networks that preserved and transmitted sophisticated medical information across vast distances. Similar therapeutic techniques appear in isolated communities with no apparent regular contact. Medical terminology and diagnostic methods that show consistency across different cultural and linguistic contexts. Knowledge preservation that suggests institutional approaches to medical education rather than informal folk healing traditions. Traditional Himalayan medicine includes treatments for conditions that mainstream medicine did not recognize until modern times. Descriptions of high-altitude sickness and therapeutic approaches that anticipate modern understanding of hypoxic conditions. Treatments for radiation-related health effects that seem to anticipate exposure conditions not relevant to pre-industrial societies. Medical knowledge that suggests awareness of health challenges that should not have existed in ancient environments. The psychological and spiritual components of Himalayan healing traditions demonstrate understanding of mind-body connections and therapeutic relationships that modern medicine has only recently begun to recognize. Meditation techniques used as medical interventions for specific physical conditions. Visualization practices that allegedly influence immune system function and healing responses. Therapeutic approaches that integrate psychological, spiritual, and physical treatment modalities in systematic ways. Modern pharmacological research has confirmed the therapeutic effectiveness of many traditional Himalayan medicinal formulations. Plant compounds used in ancient preparations that demonstrate significant biological activity in laboratory testing. Traditional drug combinations that show synergistic effects that enhance therapeutic outcomes. Ancient pharmaceutical knowledge that anticipates discoveries made by modern drug development research. The training methods described in traditional medical texts suggest educational systems that could produce healers with capabilities exceeding typical traditional medicine practitioners. Curriculum descriptions that include anatomy, pharmacology, diagnostic techniques, and therapeutic methods requiring years of specialized study. Educational approaches that suggest institutional medicine with professional standards and systematic knowledge transmission, rather than informal apprenticeship systems. Some traditional medical texts describe therapeutic techniques that claim to enhance human capabilities beyond normal physiological limitations. Methods for improving memory, cognitive function, and sensory perception through medicinal interventions. Practices for increasing resistance to altitude, cold, and other environmental stresses. Therapeutic approaches that suggest understanding of human potential and optimization techniques beyond conventional medical goals. The preservation of advanced medical knowledge in isolated Himalayan communities raises questions about the sources and development of sophisticated therapeutic systems. Whether ancient healers had access to lost medical traditions, developed advanced techniques through systematic experimentation, or received knowledge through sources not documented in conventional medical history. Their achievements suggest that traditional Himalayan medicine represents more than folk healing practices. The medical traditions indicate sophisticated understanding of human biology and therapeutic techniques that challenge assumptions about ancient medical capabilities and suggest that the high mountains have preserved healthcare knowledge systems that modern medicine is only beginning to recognize and understand. But deep in the most remote glacial valleys, mountaineers report phenomena that challenge conventional understanding of ice physics and atmospheric optics. Glowing ice formations that emit light without apparent energy source. Luminescent patterns that appear in glacial surfaces during specific weather conditions. Ice caves that display phosphorescent properties that cannot be explained through known geological or atmospheric processes. These anomalous observations suggest that the extreme conditions of high-altitude environments might create optical phenomena that mainstream science has not yet documented or explained. The first documented reports of glowing ice came from British expeditions in the early 20th century. Climbers described ice formations that appeared to generate their own light during clear, moonless nights. Photographs attempted during these conditions show unusual luminescence that photographic experts could not attribute to normal light sources or camera effects. Expedition logs preserve detailed descriptions of the phenomena that include timing, weather conditions, and geographical locations where the glowing ice was observed. Local Sherpa guides distinguish between different types of luminous ice phenomena. They describe formations that glow with steady light and others that pulse or change intensity over time. Ice that appears blue-white and other formations that emit greenish or reddish light. Traditional knowledge includes techniques for predicting when and where glowing ice is likely to appear based on weather patterns, seasonal timing, and geographical factors. Scientific analysis of ice samples from locations where luminescence was reported has yielded inconclusive results. Chemical composition that matches normal glacial ice without unusual mineral inclusions or organic contamination. Crystalline structure that appears identical to regular ice formation, despite reported optical properties. Laboratory testing that fails to reproduce luminescent effects under controlled conditions using samples from sites where glowing was observed in natural settings. The geographical distribution of glowing ice reports shows clustering around specific geological features. Phenomena most commonly observed near areas with high mineral content in surrounding rock formations. Luminescent ice appears more frequently in valleys with specific orientations relative to magnetic north. Geographic patterns that suggest the phenomena might depend on interactions between ice formation and local, geological, or magnetic conditions. Atmospheric conditions during glowing ice observations show consistent patterns that might explain the phenomena through interactions between ice crystals and electromagnetic fields. Reports clustering during periods of high solar activity and geomagnetic storms. Luminescent ice appears most frequently during specific atmospheric pressure conditions and wind patterns. Weather correlations that suggest the phenomena might result from interactions between ice formation and electrical activity in the atmosphere. Expedition teams equipped with scientific instruments have attempted to document and measure the glowing ice phenomena under controlled conditions. Spectroscopic analysis during observed luminescence that identifies light wavelengths and intensity patterns. Electromagnetic field measurements that detect unusual electrical activity in areas where glowing ice appears. Temperature and atmospheric monitoring that documents environmental conditions during luminescent episodes. Some researchers propose that the glowing ice phenomena result from bioluminescent organisms that survive in extreme cold conditions. Bacterial or algae populations that might persist in ice formations and produce light under specific environmental conditions. Biological explanations that would account for the organic appearance of the luminescence and its correlation with seasonal and weather patterns. Microbiological research that investigates whether ice formations can support life forms capable of producing visible light. Alternative theories suggest that the phenomena result from piezoelectric effects in ice crystals subjected to stress from glacial movement and temperature changes. Electrical charges generated by mechanical stress in ice formations that create visible light under specific conditions. Physical processes that might explain the correlation between glowing ice and seismic activity or temperature fluctuations in glacial environments. The optical properties of glowing ice differ from known forms of natural luminescence in several important respects. Light emission that appears to come from within the ice rather than from surface effects. Luminescence that maintains consistency across time periods longer than typical phosphorescent materials should sustain. Optical effects that suggest energy sources or emission mechanisms beyond conventional fluorescence or phosphorescence processes. Photographic documentation of glowing ice faces technical challenges that make verification difficult. Camera equipment that malfunctions in extreme cold conditions when luminescent effects are most visible. Light levels that fall below detection thresholds for normal photographic equipment. Environmental conditions that create technical difficulties for reliable documentation while the phenomena are occurring. Cultural traditions in Himalayan regions include references to glowing ice that predate modern mountaineering and scientific observation. Traditional stories that describe luminescent ice formations as supernatural phenomena with spiritual significance. Oral histories that preserve knowledge about seasonal timing and geographical locations where glowing ice appears. Cultural knowledge that suggests the phenomena have been observed and documented through traditional means for centuries before scientific investigation. The implications of genuine luminescent ice phenomena extend beyond simple curiosity about unusual optical effects. If the observations represent previously unknown physical processes, they might indicate that extreme environmental conditions create effects that challenge conventional understanding of physics and chemistry. The phenomena might reveal interactions between electromagnetic fields, crystalline structures, and biological processes that operate only under the specific conditions found in high-altitude glacial environments. Whether glowing ice represents unknown physical processes, biological phenomena, or observational effects that have been misinterpreted, the reports highlight the extent to which extreme Himalayan environments might harbor phenomena that mainstream science has not yet documented or explained. The mountains continue to present mysteries that challenge assumptions about what forms of natural phenomena are possible under conditions that push the limits of terrestrial environmental extremes. As the Earth rotates through its ancient dance with celestial bodies, the extreme altitudes of the Himalayas provide observation platforms that offer unique advantages for astronomical study, while simultaneously creating conditions that might preserve evidence of advanced ancient astronomical knowledge. The thin atmosphere at high altitude reduces atmospheric distortion of celestial observations. The isolation from light pollution creates viewing conditions superior to most locations on Earth. These natural advantages might explain why ancient astronomical traditions developed sophisticated knowledge systems that seem to exceed the technological capabilities typically attributed to pre-modern civilizations. Observatory platforms discovered at extreme altitudes demonstrate construction and positioning techniques that optimize astronomical observation while requiring engineering capabilities that challenge conventional understanding of ancient building methods. Stone structures are positioned to track specific stellar movements across seasonal cycles. Architectural alignments that account for precession and other long-term astronomical changes. Observatory design that suggests understanding of atmospheric effects, optical principles, and mathematical astronomy beyond casual sky watching. The mathematical precision of astronomical alignments in high-altitude structures exceeds what should be possible using observational techniques available to ancient astronomers. Stellar alignments accurate to fractions of degrees that approach the limits of naked eye observation under ideal conditions. Calculations that account for atmospheric refraction and other optical effects that require understanding of advanced observational astronomy. Precision that suggests access to measurement techniques or calculation methods beyond what Bronze Age or Iron Age technology should provide. Ancient astronomical instruments discovered at high-altitude sites demonstrate metallurgy and precision manufacturing that challenges understanding of ancient technical capabilities. bronze and brass components machined to tolerances that require sophisticated metalworking techniques, gear mechanisms that demonstrate understanding of mechanical engineering and precision manufacturing, optical components that suggest knowledge of lens grinding and optical instrument construction centuries before such technology appeared in mainstream scientific development. The preservation of astronomical knowledge and high-altitude monastery libraries includes calculations and predictions that demonstrate observational capabilities spanning centuries of systematic sky watching, star catalogs that list celestial coordinates with precision, matching modern astronomical measurements, eclipse predictions that maintain accuracy across decades of verification, calendar systems that account for multiple astronomical cycles simultaneously while maintaining long-term accuracy. Certain astronomical traditions preserved in Himalayan monasteries describe observation techniques that claim to enhance human visual perception beyond normal capabilities, meditation practices that allegedly improve night vision and stellar observation abilities, techniques for detecting celestial phenomena that are normally invisible to naked eye observation, methods that might represent genuine approaches to optimizing human sensory capabilities for astronomical observation under extreme conditions. The geographical positioning of astronomical sites across the Himalayan region creates networks of observation points that enable coordinated sky watching across vast distances. Site placement that provides overlapping coverage of celestial events from multiple geographical perspectives. Communication systems that allegedly allowed coordination of observations between distant locations. Networks that suggest institutional approaches to astronomical research rather than individual observer projects. Advanced calendrical systems used in Himalayan regions demonstrate mathematical sophistication that exceeds what agricultural societies typically develop. Calendar calculations that integrate multiple astronomical cycles, including solar years, lunar months, planetary periods, and precession cycles. Mathematical techniques that maintain accuracy across centuries while accounting for irregularities in celestial mechanics. Calendrical knowledge that suggests professional astronomer classes with advanced mathematical education. The integration of astronomical knowledge into architectural and landscape design demonstrates understanding of relationships between celestial mechanics and terrestrial geography that require sophisticated scientific knowledge. Building orientations that optimize solar heating and lighting based on seasonal sun angles. Landscape modifications that enhance astronomical visibility while providing practical benefits for agriculture and water management. Design integration that suggests systematic application of astronomical knowledge to practical engineering problems. Some astronomical traditions describe prediction techniques that extend beyond normal observational astronomy into areas that modern science considers impossible or impractical. Methods for predicting weather patterns based on astronomical observations extending seasons or years in advance. Techniques for correlating celestial events with terrestrial phenomena, including earthquakes, climate changes, and biological cycles. Predictive capabilities that suggest understanding of connections between cosmic and terrestrial systems beyond conventional astronomical knowledge. Modern verification of ancient astronomical predictions using computer modeling and historical records confirms accuracy levels that exceed what observational techniques available to ancient astronomers should have achieved. Eclipse predictions that maintain precision across centuries of verification. Planetary position calculations that match modern computational astronomy. Astronomical knowledge that anticipates discoveries made by telescopic observation centuries later. The correlation between astronomical knowledge and other advanced capabilities preserved in Himalayan tradition suggests integrated knowledge systems that combine multiple scientific disciplines. Astronomical techniques used in medical diagnosis and treatment timing. Mathematical methods applied to architecture, engineering, and agricultural planning. Knowledge integration that suggests educational institutions capable of training practitioners in multiple scientific specializations simultaneously. High-altitude environmental conditions create unique challenges and opportunities for astronomical observation that might have encouraged development of specialized techniques and instruments. Atmospheric conditions that require correction factors for accurate celestial measurement. Environmental extremes that demand specialized equipment and observation methods. Conditions that might have encouraged innovation in astronomical techniques beyond what lower altitude observers developed. The astronomical mysteries of the Himalayas represent more than simple questions about ancient scientific capabilities. They suggest that extreme mountain environments might have served as centers for sophisticated astronomical research that preserved and developed knowledge systems, exceeding mainstream scientific development. Whether ancient Himalayan astronomers had access to advanced technologies, developed enhanced observation techniques, or received knowledge through sources not documented in conventional scientific history, their achievements indicate that the world's highest places might have been laboratories for cosmic observation and scientific discovery that challenged the boundaries of human knowledge and capability. Centuries earlier, as political upheavals and cultural changes swept across the lowland civilizations, certain knowledge-keeping communities retreated to the most inaccessible regions of the Himalayas. These groups, operating beyond the reach of conventional political authority, developed sophisticated systems for preserving and protecting information that they considered essential for human survival and development. Their traditions speak of deliberate withdrawal from mainstream society to maintain knowledge systems that external pressures might destroy or corrupt. Secret societies that function as living libraries, preserving technical knowledge, historical records, and spiritual practices across generations of careful transmission. The Bon tradition, predating Buddhist influence in the Himalayas, preserves accounts of knowledge keepers who withdrew to hidden valleys during periods of cultural conflict. These communities allegedly maintained libraries of texts covering astronomy, medicine, engineering, and other technical subjects. Oral traditions describe systematic efforts to preserve knowledge by copying important texts, training specialized memory keepers, and establishing hidden repositories in locations protected by natural barriers and deliberate concealment. Monastery networks throughout the Himalayas maintain communication systems that operate beyond normal religious or political channels. Encrypted message systems using symbolic codes that preserve secrecy while enabling coordination across vast distances. Knowledge-sharing protocols that prioritize preservation of specific information categories. Communication networks that suggest institutional approaches to knowledge management and protection rather than casual scholarly exchange. The tradition of terma, or hidden teachings, represents a systematic approach to concealing and recovering important information during times of social upheaval. Knowledge deliberately hidden in physical locations, embedded in artistic works, or preserved in human memory using specialized techniques. Recovery systems that depend on specific individuals appearing at predetermined times with appropriate training and authorization. Methods that ensure knowledge survival across periods when open preservation would be impossible or dangerous. Training systems for knowledge keepers demonstrate educational approaches that exceed typical monastic or scholarly instruction. Curriculum that combines memory techniques, encryption methods, specialized languages, and technical skills for manuscript preservation. Educational programs that prepare individuals to serve as living libraries capable of preserving vast amounts of information without written records. Training that creates professional knowledge preservers with capabilities beyond normal scholarly or religious education. The geographical distribution of knowledge-keeping communities follows patterns that optimize both security and communication while maintaining access to necessary resources. Settlements positioned in locations that provide natural protection while maintaining contact with trade routes and information networks. Site selection that balances isolation requirements with practical needs for survival and knowledge transmission. Strategic positioning that suggests coordinated planning and resource management across multiple communities. Certain secret societies preserve technical knowledge that exceeds what their historical context should have provided. Engineering information that describes construction techniques beyond known capabilities of relevant time periods. Scientific knowledge that anticipates discoveries made centuries later by mainstream research. Technical preservation that suggests access to advanced knowledge sources or development of sophisticated research capabilities in isolation from mainstream civilization. The membership systems of knowledge-keeping societies demonstrate selection and training methods designed to ensure loyalty and competence across generations of changing conditions. Initiation processes that test psychological stability, intellectual capability, and commitment to knowledge preservation goals. Training programs that prepare members to operate effectively under various social and political conditions. Organizational methods that maintain institutional continuity across centuries of external change and internal generational transition. Protection methods used by secret societies extend beyond simple concealment to active measures for preserving knowledge integrity and preventing unauthorized access. Encryption techniques that protect information content while allowing transmission between authorized individuals. Verification systems that prevent knowledge corruption through transcription errors or deliberate falsification. Security measures that balance protection requirements with practical needs for knowledge access and transmission. Some traditions describe knowledge-keeping societies that maintain contact with similar organizations in distant geographical regions. International networks that coordinate knowledge preservation and sharing across cultural and political boundaries. Communication systems that enable cooperation between groups with different languages, traditions, and organizational structures. Coordination that suggests institutional approaches to global knowledge management and preservation. The content categories preserved by secret societies indicate systematic approaches to identifying and protecting information considered essential for human survival and development. Technical knowledge covering medicine, engineering, agriculture, and other practical applications. Historical records that preserve information about past civilizations and cultural developments. Scientific knowledge covering astronomy, mathematics, and natural philosophy beyond mainstream educational systems. Modern encounters with individuals claiming membership in traditional knowledge-keeping societies have produced information that suggests continuation of ancient preservation systems into contemporary times. Demonstrations of memory techniques and specialized knowledge that exceed normal educational capabilities. Descriptions of organizational structures and knowledge categories that align with historical accounts of secret societies. Evidence that suggests traditional knowledge preservation systems might continue to operate in modified forms adapted to modern conditions. The verification of knowledge preserved by secret societies presents challenges for conventional scholarly research. Information sources that require authentication through traditional means rather than standard academic verification. Knowledge claims that can only be evaluated through specialized techniques not available to mainstream researchers. Evidence that exists primarily in oral traditions and memory systems rather than written documentation accessible to external investigation. The implications of genuine secret societies operating as knowledge preservation systems extend beyond historical curiosity to questions about information management and cultural continuity. If traditional preservation systems have maintained technical and historical knowledge across centuries of changing conditions, they might represent alternative approaches to education and information preservation that modern societies could learn from or adapt. The secret societies of the Himalayas might function as proof-of-concept demonstrations for knowledge preservation systems that operate independently of conventional educational and political institutions, maintaining cultural and technical knowledge through methods that prioritize long-term preservation over short-term accessibility or political control. But among the countless unnamed summits that pierce the Himalayan sky, one mountain has earned a reputation that keeps even the most experienced climbers away. Kanken Dorje, known locally as the Whispering Peak, rises in isolation from the main ridge systems. Modern mountaineers who attempt to climb its slopes report acoustic phenomena that cannot be explained through normal atmospheric effects or psychological stress. Voices speaking in languages that no expedition member recognizes. Conversations that seem to emerge from the mountain itself. Sounds that suggest human presence where no humans should exist. The first documented encounter with the Whispering Peak as acoustic anomalies occurred during a British survey expedition in 1934. The Teen S leader, Colonel James Whitmore, recorded detailed accounts of voices heard at elevations above 20,000 feet. The voices spoke in what appeared to be coherent languages with consistent grammar and vocabulary. Multiple expedition members confirmed the observations. Sound recording equipment of the era captured audio that analysis could not attribute to wind effects, avalanche noise, or equipment malfunction. Local Sherpa guides describe the voices as communications between guardian spirits who protect hidden knowledge stored within the mountain. Traditional accounts speak of ancient peoples who entered the mountain during times of great danger and never emerged. Oral histories that preserve specific details about the types of voices heard and the languages they use. Cultural knowledge that treats the acoustic phenomena as evidence of ongoing spiritual activity, rather than natural geological processes. Acoustic analysis of the Whispering Peak as geological structure reveals cave systems and internal chambers that could create resonance effects and sound amplification under specific atmospheric conditions. The mountain's internal geometry might function as a natural sound system that amplifies and transmits audio from hidden sources. Geological features that could explain how voices from concealed locations might become audible at distant points on the mountain's surface. Modern climbing expeditions equipped with digital recording equipment have documented audio phenomena that resist conventional explanation. Sound files that capture clear human voices speaking in linguistic patterns that do not match any known language families. Recordings that include multiple speakers engaged in what appears to be conversation or discussion. Audio evidence that suggests organized human activity in locations where survival should be impossible. The linguistic analysis of recorded voices has identified grammatical structures and vocabulary patterns that appear consistent within individual recording sessions, but vary between different expeditions. The voices demonstrate linguistic sophistication, including complex sentence structures, technical terminology, and emotional inflection. Language characteristics that suggest native speakers rather than random vocal sounds or atmospheric effects mimicking human speech. Expedition members report that the voices seem to respond to human presence and activity. Conversations that pause when climbers approach and resume when they move away. Vocal patterns that change in intensity and frequency based on weather conditions and time of day. Interactive elements that suggest awareness of observer presence rather than random acoustic phenomena or pre-recorded material. The geographical distribution of voice phenomena on the Whispering Peak correlates with locations where geological surveys have identified unusual subsurface structures. Areas where the voices are most clearly heard correspond to regions where ground-penetrating radar indicates internal chambers and void spaces. Acoustic hotspots that align with geological features that could support hidden human habitation or storage of voice-producing mechanisms. Technical analysis of the voice recordings reveals audio characteristics that challenge conventional understanding of sound transmission in high-altitude environments. Voice clarity that exceeds what atmospheric conditions should allow at extreme elevation. Sound quality that suggests close proximity recording despite being captured at locations where no speakers are visible. Audio properties that indicate artificial enhancement or unusual transmission methods. Some researchers propose that the voice phenomena result from atmospheric conditions that create acoustic mirages, transmitting sounds from distant human settlements to locations where they should not be audible. Scientific explanations that account for sound transmission across impossible distances through unusual atmospheric layering effects. Physical processes that might explain clear human voices in locations far from any known human habitation. Alternative theories suggest that the voices originate from hidden communities that have adapted to survival in extreme mountain conditions. Concealed settlements that use natural acoustic properties to communicate across distances without revealing their locations. Human groups that have developed techniques for living undetected in environments that challenge conventional survival capabilities. The psychological impact of the voice phenomena on expedition numbers creates additional challenges for objective documentation and analysis. Climbers report feelings of being watched or followed after hearing the voices. Psychological effects that include anxiety, disorientation, and compulsive desire to locate the source of the sounds. Mental health impacts that suggest the phenomena create stress responses beyond normal expedition challenges. Cultural significance of the Whispering Peak extends beyond simple mystery to questions about spiritual and supernatural phenomena in extreme environments. Local traditions that treat the mountain as a portal between different realms of existence. Religious practices that incorporate the voice phenomena into ceremonies and spiritual observances. Cultural integration that suggests the acoustic anomalies have influenced regional spiritual and philosophical development. Whether the Whispering Peak's voices represent hidden human communities, unknown acoustic phenomena, or something beyond conventional scientific categories, they illustrate the continuing mysteries that surround the Himalayas' most isolated locations. The mountain serves as a reminder that extreme environments might harbor phenomena that challenge assumptions about what forms of existence are possible in the world's most inhospitable places, where the boundaries between natural and supernatural, known and unknown, might blur in ways that conventional understanding has yet to recognize or explain. As the planet's climate continues its accelerating transformation, the ancient ice of the Himalayas retreats at rates that have no precedent in human memory. Glaciers that have persisted for millennia now release their frozen archives with unprecedented speed. This climatic upheaval creates both opportunities and urgencies for researchers seeking evidence of ancient civilizations. Materials that have remained hidden beneath ice for thousands of years now emerge into sunlight for the first time since they were originally buried. Archaeological treasures and lost knowledge systems face simultaneous revelation and destruction as changing conditions expose them to forces that threaten their preservation. The rate of glacial retreat in the Himalayas has accelerated dramatically over recent decades. Satellite imagery shows ice loss patterns that expose surfaces not seen for millennia. Areas that were permanently frozen now experience seasonal melting. Valley systems that were inaccessible due to glacial coverage now provide access to previously hidden terrain. The speed of change creates opportunities for discovery while simultaneously threatening to destroy evidence before it can be properly studied and preserved. Archaeological discoveries emerging from melting ice reveal human presence at altitudes and time periods that challenge conventional understanding of ancient adaptation capabilities. Organic materials preserved in perfect condition by glacial ice show evidence of sophisticated textile production, tool manufacturing, and artistic development. Wooden artifacts demonstrate woodworking techniques and tool technologies that exceed what survival conditions should have allowed. Cultural materials that suggest permanent settlement rather than temporary survival shelters. The preservation conditions within glacial ice have maintained organic materials with fidelity that exceeds most other archaeological contexts. DNA samples remain intact enough for genetic analysis. Protein structures maintain their molecular organization. Even cellular structures survive in recognizable form after thousands of years of frozen storage. The quality of preservation provides unprecedented opportunities for understanding ancient human biology, diet, health, and cultural practices. Dating analysis of materials emerging from Himalayan glaciers indicates human presence during climate periods when the mountains should have been even more hostile to habitation than current conditions. Radiocarbon dates that place human activity during glacial maximum periods when temperatures were significantly lower than present levels. Evidence of sustained habitation during climate periods that should have made high-altitude survival impossible using known adaptation techniques. The geographical distribution of materials emerging from glacial retreat suggests organized communities rather than isolated survival attempts. Artifact concentrations that indicate permanent settlements with specialized activity areas. Tool assemblages that suggest division of labor and professional specialization beyond subsistence requirements. Cultural materials distributed in patterns that indicate planned community development and resource management systems. Advanced dating techniques applied to glacially preserved materials reveal temporal patterns that suggest continuous or repeated occupation across extended time periods. Stratified deposits that show multiple phases of human activity separated by periods of abandonment or reduced presence. Occupational patterns that correlate with climate cycles can suggest adaptive strategies for surviving environmental changes across centuries or millennia. The technological sophistication demonstrated by glacially preserved artifacts challenges assumptions about ancient adaptation capabilities in extreme environments. Metallurgy techniques that produce alloys requiring advanced smelting knowledge and temperature control. Textile production that demonstrates advanced fiber processing and weaving technologies. Tool manufacture that suggests understanding of materials science and engineering principles beyond basic survival requirements. Climate modeling indicates that the Himalayas experienced periods of relative warming that could have supported advanced civilizations at altitudes that are currently marginal for human habitation. During these warmer periods, agricultural zones would have extended to higher elevations. Water resources would have been more abundant and reliable. Weather patterns would have been more stable and predictable. Environmental conditions that could have supported sophisticated societies with capabilities for monumental construction and advanced cultural development. The artistic and cultural materials emerging from glacial retreat demonstrate aesthetic sophistication and symbolic complexity that indicates advanced cultural development. Decorative objects that suggest leisure time and cultural activities beyond survival requirements. Symbolic systems that indicate complex language and communication capabilities. Artistic traditions that demonstrate cultural continuity and institutional knowledge preservation across generations. Some researchers propose that ancient Himalayan civilizations might have deliberately used glacial environments for long-term storage and preservation of important materials. Cultural practices that recognized the preservation potential of glacial ice and systematically deposited important items in locations where they would remain frozen until future recovery. Storage systems that demonstrate understanding of glacial mechanics and long-term environmental planning. The correlation between glacial retreat and archaeological discovery creates research opportunities that may be time-limited. As glaciers continue to retreat, they expose materials that may have only brief windows of accessibility before changing conditions destroy them. Archaeological sites that emerge from ice face immediate threats from erosion, temperature fluctuations, and biological decay. Research programs that must balance thorough investigation with rapid documentation and preservation needs. Modern technology provides tools for studying glacially preserved materials that were not available to earlier researchers. DNA sequencing techniques that can identify species and populations from microscopic samples. Chemical analysis that can determine diet, health status, and environmental conditions from preserved tissues. Imaging technologies that can reveal internal structures and manufacturing techniques without damaging fragile artifacts. The implications of advanced civilizations preserved in Himalayan glaciers extend beyond archaeological curiosity to questions about human adaptation. technological development, and cultural continuity under extreme conditions. If sophisticated societies did develop in high-altitude environments during ancient climate periods, they might have developed technologies and cultural practices that modern societies could learn from. Ancient adaptation strategies might provide insights for dealing with contemporary climate challenges and extreme environment survival. The race between glacial retreat and archaeological preservation creates urgent priorities for Himalayan research. Each season brings new exposures, but also threatens to destroy materials that have waited millennia for discovery. The mountains serve as natural museums, whose collections are simultaneously opening and closing, revealing secrets while destroying evidence, creating opportunities for understanding ancient human achievement while threatening to erase the very proof of that achievement before it can be fully documented and understood. As geological time unfolds across millions of years, the Himalayas themselves function as vast repositories where the Earth's deep history intersects with human memory and mythological preservation. The mountains serve as three-dimensional libraries where geological processes, climate records, and human cultural development create layered archives that preserve information across time scales that span from individual lifetimes to planetary evolution. Understanding the Himalayas requires reading multiple simultaneous narratives: geological formation, climate history, biological evolution, and human cultural development. Each story informs the others, creating comprehensive archives that preserve the past while shaping the future. The geological formation of the Himalayas created preservation conditions that function like natural time capsules across multiple temporal scales. Rock layers that preserve ancient climate conditions through fossil and chemical evidence. Sedimentary deposits that maintain records of atmospheric composition across geological periods. Mineral formations that preserve evidence of ancient biological activity and environmental conditions. Geological processes that create natural storage systems for materials, ranging from microscopic organisms to massive structural remains. Climate records preserved in Himalayan ice cores, lake sediments, and geological formations provide continuous documentation of environmental conditions across hundreds of thousands of years. Temperature variations that correlate with global climate patterns and regional environmental changes. Atmospheric composition data that tracks the chemical evolution of Earth's climate system. Precipitation patterns that document the long-term relationship between global climate and regional weather systems. The biological evolution preserved in Himalayan environments demonstrates adaptation strategies that span from microscopic organisms to complex ecosystems. High-altitude adaptations that showcase biological responses to extreme environmental conditions. Evolutionary pressures that created specialized life forms adapted to conditions found nowhere else on Earth. Biological archives that preserve genetic information about adaptation strategies and evolutionary pathways under extreme environmental stress. Human cultural development in the Himalayas creates additional layers of historical preservation through oral traditions, architectural remains, and cultural practices that maintain continuity across centuries. Memory systems that preserve technical knowledge, historical events, and cultural practices without depending on written documentation. Cultural institutions that maintain information preservation across generations of changing environmental and social conditions. Traditional knowledge systems that integrate human cultural development with understanding of natural environmental patterns. The intersection between geological and human timescales in the Himalayas creates unique opportunities for understanding long-term relationships between environmental change and human cultural adaptation. Archaeological sites that preserve human responses to climate changes across millennia. Cultural practices that demonstrate human adaptation to environmental conditions that required long-term planning and institutional knowledge preservation. Human modifications of landscape that interact with geological processes across timescales that span individual lifetimes, and institutional continuity. Traditional ecological knowledge preserved in Himalayan cultures demonstrates sophisticated understanding of environmental systems that integrate scientific observation with cultural practice. Agricultural techniques adapted to high-altitude conditions that demonstrate understanding of soil science, climate patterns, and biological relationships. Water management systems that work with geological and hydrological processes while meeting human community needs. Cultural practices that maintain sustainable relationships with environmental systems across centuries of changing conditions. The oral traditions preserved in Himalayan cultures function as historical archives that maintain information about past environmental conditions, cultural events, and technical knowledge. Mythological narratives that preserve memories of major climate events, geological changes, and cultural migrations. Story systems that encode technical information about survival techniques, resource management, and environmental prediction within cultural and religious frameworks. Memory traditions that maintain accuracy across generations through systematic preservation and verification methods. Astronomical observations preserved in Himalayan traditions demonstrate long-term scientific investigation that connects human cultural development with cosmic phenomena. Calendrical systems that maintain accuracy across centuries while integrating multiple astronomical cycles with agricultural and cultural timing. Observatory traditions that preserve knowledge of celestial mechanics through systematic observation programs spanning multiple generations. Scientific knowledge that demonstrates institutional approaches to long-term research and knowledge preservation. The preservation of advanced technical knowledge in Himalayan traditions suggests cultural institutions capable of maintaining sophisticated information systems across centuries of changing social and environmental conditions. Engineering knowledge that demonstrates understanding of principles and techniques beyond what survival conditions typically support. Medical knowledge that demonstrates systematic research and development in pharmaceutical and therapeutic techniques. Scientific traditions that suggest educational institutions and professional specialization beyond subsistence-level social organization. Modern research techniques provide new methods for reading the multiple historical archives preserved in Himalayan environments. Geological dating techniques that can correlate human cultural development with environmental changes across extended time periods. Climate reconstruction methods that can relate cultural practices to specific environmental conditions and climate patterns. Archaeological techniques that can identify human modifications of natural systems and their long-term environmental effects. The integration of multiple temporal scales and information systems in Himalayan research creates opportunities for understanding relationships between geological, climate, biological, and cultural development that are not available in most other environments. The mountains provide natural laboratories where different temporal processes intersect and interact in ways that create comprehensive historical records. Research opportunities that can inform understanding of long-term relationships between environmental change and human cultural development. The concept of the Himalayas as planetary memory systems suggests extreme environments might serve essential functions in maintaining Earth as historical archives. The preservation conditions created by extreme altitude, climate, and geological activity might be necessary for maintaining certain types of historical information across geological timescales. Environmental protection of Himalayan regions might be essential not only for current ecological function, but for maintaining access to historical archives that contain information essential for understanding Earth as long-term environmental and cultural development. The Himalayas represent more than geographical features or tourist destinations. They function as integrated memory systems where geological, climate, biological, and human cultural development create comprehensive archives that preserve the past while providing information essential for understanding current conditions and predicting future changes. The mountains serve as libraries, laboratories, and museums where multiple temporal processes interact to create knowledge systems that span from individual human memory to planetary evolution, making them essential resources for understanding the deep relationships between environmental conditions and the development of life, consciousness, and cultural sophistication on Earth. Meanwhile, in the deepest valleys where conventional archaeology rarely ventures, evidence suggests that ancient Himalayan civilizations might have developed technologies that operated on principles different from modern scientific understanding. Energy systems that leave no trace in the archaeological record. Construction techniques that exceed current engineering capabilities while using materials and methods that decompose completely over time. Scientific knowledge that anticipates discoveries that mainstream research has only recently achieved. These possibilities challenge fundamental assumptions about technological development and suggest that ancient peoples might have explored scientific pathways that modern civilization has overlooked or abandoned. The construction techniques preserved in megalithic Himalayan sites demonstrate engineering capabilities that challenge understanding of ancient technological possibilities. Stone blocks weighing multiple tons are positioned with precision that exceeds modern construction standards. Joints fitted so precisely that gaps are nearly invisible despite centuries of thermal expansion and seismic activity. Construction quality that suggests access to tools and techniques that leave no archaeological trace, while achieving results that challenge current engineering capabilities. Some researchers propose that ancient civilizations might have developed acoustic technologies that could manipulate matter using sound waves and resonance effects. Theoretical applications of acoustic principles that could move heavy objects, cut stone, or modify material properties using vibrational techniques. Scientific principles that would not require metal tools or mechanical devices while potentially achieving construction capabilities that exceed conventional engineering methods. Technologies that would leave minimal archaeological evidence while explaining construction achievements that challenge understanding of ancient capabilities. The metallurgy preserved in ancient Himalayan artifacts demonstrates knowledge of alloys and processing techniques that anticipate modern materials science discoveries. Metal compositions that suggest understanding of atomic structure and chemical bonding principles. Processing techniques that achieve material properties through methods that modern metallurgy has only recently developed. Knowledge that suggests access to theoretical understanding or experimental techniques that exceed what ancient technological development should have provided. Energy systems described in ancient texts suggest technologies that operate on principles that mainstream physics has not yet recognized or fully developed. Descriptions of power sources that draw energy from environmental fields or cosmic radiation. Technical knowledge that suggests understanding of energy principles beyond chemical combustion or mechanical force application. Energy technologies that would not leave archaeological traces while potentially providing power for advanced construction and manufacturing techniques. The mathematical knowledge preserved in Himalayan traditions demonstrates understanding of principles that anticipate discoveries made centuries later by mainstream mathematics and physics. Geometric techniques that suggest understanding of higher dimensional mathematics and complex numerical relationships. Calculation methods that demonstrate knowledge of advanced mathematical principles beyond what ancient educational systems should have been able to develop or transmit. Knowledge that suggests access to mathematical insights that mainstream academic development achieved only recently. Some ancient texts describe transportation technologies that allegedly enabled movement of people and materials across impossible distances without leaving evidence of conventional travel infrastructure. Descriptions of flight capabilities using principles that do not match known historical aviation development. Transportation methods that suggest understanding of physical principles beyond mechanical engineering and chemical propulsion. Technologies that would explain how ancient civilizations maintained communication and coordination across vast geographical distances without conventional transportation infrastructure. Medical knowledge preserved in ancient Himalayan traditions suggests understanding of biological processes and therapeutic techniques that anticipate discoveries made by modern biomedical research. Descriptions of surgical procedures that demonstrate anatomical knowledge beyond what dissection and observation alone should provide. Pharmaceutical techniques that suggest understanding of biochemical processes and drug interactions at molecular levels. Medical knowledge that indicates research capabilities and theoretical understanding beyond what ancient educational institutions should have been able to develop. The astronomical instruments preserved in Himalayan monasteries demonstrate precision manufacturing and optical knowledge that challenges understanding of ancient technological capabilities. Mechanical components that suggest understanding of gear ratios and precision engineering beyond what known ancient metallurgy should accomplish. Optical elements that demonstrate knowledge of lens grinding and light manipulation principles. Instrument construction that suggests access to manufacturing. Techniques that leave no archaeological trace while producing results that challenge. CONVENTION technological development timelines. Communication technologies described in ancient traditions suggest methods for transmitting information across distances that exceed what known ancient communication methods should accomplish. Descriptions of instantaneous communication between distant locations using methods that do not require physical message transmission. Technologies that suggest understanding of electromagnetic principles or other physical phenomena beyond what ancient scientific knowledge should have included. Communication capabilities that would explain coordination of construction and cultural activities across vast geographical distances. Advanced materials described in ancient texts suggest manufacturing techniques that could produce substances with properties exceeding what known historical materials science should accomplish. Descriptions of materials with characteristics that anticipate modern composite manufacturing and nanotechnology applications. Processing techniques that suggest understanding of atomic and molecular manipulation beyond what ancient chemistry should have provided. Materials science that would explain construction achievements while potentially decomposing over time without leaving archaeological evidence. The integration of multiple advanced technologies in ancient systems suggests educational institutions and research capabilities that exceed what historical reconstructions typically propose for ancient civilizations. Technological knowledge that combines multiple scientific disciplines in ways that require institutional research and professional specialization. Educational systems capable of training practitioners in advanced technical subjects across multiple generations of knowledge preservation and development. Institutional capabilities that suggest social organization beyond subsistence-level survival and simple agricultural communities. Modern physics has begun to explore principles that might validate some ancient technological descriptions previously dismissed as impossible or mythological. Quantum mechanics principles that suggest possibilities for matter manipulation using field effects and resonance phenomena. Energy physics that indicates potential power sources beyond conventional mechanical and chemical systems. Scientific developments that suggest ancient descriptions of advanced technologies might represent genuine knowledge rather than fantasy or misinterpretation. Whether ancient Himalayan civilizations actually possessed advanced technologies, had access to knowledge sources beyond conventional historical development, or developed alternative scientific pathways that modern research has not yet explored, the evidence suggests that assumptions about ancient technological limitations might be incomplete. The preservation of advanced knowledge in extreme mountain environments might indicate that human scientific capability has followed more complex pathways than conventional historical reconstruction proposes. The Himalayas might serve as repositories not only of cultural and historical knowledge, but of alternative technological possibilities that could inform modern scientific development and expand understanding of what forms of technology are possible under different conditions and using different scientific principles than those that dominate contemporary technological development. But deep within the Bhutan Himalayas, at an elevation where most humans struggle to maintain consciousness, lies a discovery that challenges every assumption about ancient knowledge preservation and the limits of human adaptation to extreme environments. The frozen library of Gangkar Puensum remains one of the most closely guarded secrets in modern archaeology. Discovered in 2019 by a team studying glacial retreat effects, this hidden complex contains thousands of texts preserved in ice formations that maintain perfect readability despite centuries of frozen storage. The discovery occurred when climate change-induced glacial melting exposed the entrance to a cave system that had been sealed by ice for an estimated 800 years. Initial exploration revealed chambers carved into bedrock with architectural precision that suggests advanced planning and engineering. The spaces were designed specifically for document storage, with natural ventilation systems that maintain consistent temperature and humidity levels. Ice formations that occurred after the original sealing created perfect preservation conditions for organic materials. The documents found within the frozen library include texts written in multiple scripts and languages, some of which remain unidentified by contemporary linguistic experts. Manuscripts on materials ranging from traditional parchment to metal plates using inscription, techniques that demonstrate sophisticated manufacturing capabilities. Text preservation that maintains ink clarity and material integrity despite centuries of extreme cold conditions. Document collections that suggest systematic library organization with classification systems for different subject categories. Subject matter covered in the preserved texts spans disciplines that exceed what medieval knowledge systems typically encompassed. Advanced mathematical treatises that demonstrate understanding of geometric principles and calculation techniques, anticipating modern mathematical developments. Medical texts describing surgical procedures and pharmaceutical preparations, using knowledge that predates known development of such medical sophistication. Engineering manuals that provide construction techniques and materials science information beyond what historical technological development should have included. The linguistic analysis of the readable texts reveals technical vocabulary and scientific terminology that suggests professional specialization and institutional education beyond what historical reconstructions propose for the relevant time periods. Scientific language that indicates systematic research and theoretical development in multiple disciplines. Technical terminology that suggests communication between specialists in different fields using standardized professional vocabulary. Educational standards that indicate institutional knowledge preservation and transmission across multiple generations. Dating analysis of the document materials and preservation conditions indicates that the library was deliberately created and sealed rather than accidentally preserved. Carbon dating shows that the documents span several centuries of production, suggesting ongoing collection and preservation activities. Sealing techniques that were designed to create optimal preservation conditions for long-term storage. Systematic organization that indicates planning for future access and knowledge recovery, rather than emergency storage during crisis situations. The construction methods used to create the frozen library demonstrate engineering knowledge that challenges understanding of medieval construction capabilities in extreme environments. Excavation techniques that remove massive quantities of bedrock while maintaining structural stability and preventing collapse. Ventilation systems that create controlled air circulation in sealed chambers. Engineering solutions that suggest understanding of physics and materials science beyond what available tools and knowledge should have accomplished. Document preservation techniques used within the library include methods that exceed known historical capabilities for protecting organic materials in extreme conditions. Chemical treatments that enhance material durability and resist degradation from temperature, humidity, and biological effects. Storage systems that protect documents from physical damage while maintaining accessibility for study and copying. Preservation methods that suggest understanding of chemistry and materials, science beyond what medieval knowledge should have included. The geographical location of the frozen library raises questions about accessibility and the communities that created and maintained it. Positioning at elevations that require specialized knowledge and equipment for safe access using historical travel methods. Location selection that provides security and isolation while requiring sophisticated logistics for construction and regular maintenance. Site placement that suggests coordination with other hidden facilities or communication networks. Content analysis of the preserved texts reveals knowledge systems that integrate multiple scientific, technical disciplines in ways that suggest advanced educational institutions and research capabilities. Mathematical knowledge applied to engineering, astronomical, and medical applications. Scientific principles that demonstrate understanding of relationships between different natural phenomena and technical applications. Knowledge integration that suggests institutional research and professional collaboration beyond individual scholarship or craft guild systems. Some preserved texts describe technologies and scientific principles that anticipate discoveries made centuries later by mainstream scientific research. Descriptions of mechanical devices that demonstrate understanding of physical principles beyond what historical technological development should have included. Scientific theories that anticipate modern discoveries in physics, chemistry, and biology. Knowledge that suggests access to research capabilities or theoretical insights beyond what ancient educational systems should have provided. The preservation of the frozen library's contents faces immediate threats from siege, climate change, and environmental degradation. Changing temperature conditions threaten to destroy documents that have remained intact for centuries. Atmospheric pressure changes affect the natural preservation systems that have protected the materials. Environmental instability that creates urgent priorities for documentation and preservation before materials are lost to changing conditions. Modern documentation techniques provide methods for studying and preserving the frozen library's contents that were not available to earlier researchers. Digital imaging that can capture document content without physical handling that might cause damage. Chemical analysis that can determine materials and preservation techniques without destructive testing. Documentation methods that can preserve information content while protecting original materials from further degradation. The implications of the frozen library extend beyond simple questions of historical knowledge preservation to fundamental issues about ancient educational capabilities and institutional development. The collection suggests systematic approaches to knowledge gathering, preservation, and organization that exceed conventional understanding of medieval institutional capabilities. Educational systems capable of training specialists in multiple technical disciplines while maintaining institutional continuity across centuries of changing conditions. Whether the frozen library represents the work of a single advanced civilization, collaborative efforts between multiple communities, or preservation of knowledge from even older sources, it demonstrates that extreme, Himalayan environments have served as repositories for sophisticated knowledge systems that challenge assumptions about ancient human capabilities. The discovery serves as proof that the world's most inaccessible places might preserve evidence of human intellectual achievement that exceeds conventional historical reconstructions and provides new insights into the sophistication of ancient knowledge systems and the human capacity for learning research and institutional development under extreme conditions. As dawn breaks across the eternal peaks, illuminating summits that have witnessed the rise and fall of countless civilizations, the Himalayas invite contemplation of humanity's deepest questions about knowledge, mystery, and the nature of existence itself. These mountains embody the fundamental tension between human curiosity and the limits of understanding. They represent the persistent allure of the unknown and the recognition that some questions might be more valuable than their answers. Standing at the intersection of earth and sky, the Himalayas serve as meditation halls for considering what it means to seek knowledge in a universe that consistently reveals new layers of complexity and wonder. The vertical dimension of the Himalayas creates metaphors that human consciousness has used across cultures and centuries to represent the relationship between earthly existence and transcendent possibility. Height becomes associated with perspective, achievement, and spiritual development. The physical challenge of ascending to extreme altitudes mirrors the intellectual and emotional challenges of pursuing understanding that transcends ordinary experience. Mountain climbing becomes a physical manifestation of philosophical aspiration, where the goal is not only to reach a destination, but to transform consciousness through the process of striving. The isolation of extreme mountain environments creates conditions that encourage introspection and philosophical reflection that are difficult to achieve in more populated and comfortable settings. Silence that allows internal dialogue to emerge without external interference. Reduced oxygen levels that may alter consciousness in ways that enhance certain types of thinking and perception. Environmental challenges that strip away non-essential concerns and focus attention on fundamental questions of survival, purpose, and meaning. Natural laboratories for exploring the relationship between physical conditions and mental states. The geological timescales represented in Himalayan landscape features provide a perspective on human existence that challenges ordinary assumptions about the significance of individual lives and cultural achievements. Rock formations that preserve evidence of processes spanning millions of years. Climate changes that occur across timescales that exceed human institutional memory. Geographical processes that continue regardless of human presence or activity. Contexts that encourage philosophical reflection on the relationship between human consciousness and cosmic processes that operate on scales beyond human control or complete comprehension. The preservation of ancient knowledge in Himalayan environments raises philosophical questions about the relationship between human understanding and the passage of time. Whether knowledge represents permanent truth that awaits discovery or historical construction that changes based on cultural context and technological capability. How human consciousness relates to information systems that exceed individual memory and institutional preservation. The significance of lost knowledge and whether understanding that disappears from human awareness continues to exist in some objective sense. The mysteries preserved in extreme mountain environments challenge assumptions about the completeness of current scientific knowledge and the relationship between rational investigation and intuitive insight. Phenomena that resist explanation using conventional scientific methods while maintaining consistency that suggests underlying patterns or principles. Experiences that suggest the existence of natural processes or consciousness capabilities beyond current theoretical frameworks. Evidence that indicates reality might be more complex and multifaceted than contemporary scientific models propose. The cultural traditions preserved in Himalayan communities demonstrate approaches to knowledge that integrate rational analysis with spiritual practice and community wisdom in ways that challenge Western educational and scientific methodologies. Knowledge systems that treat intellectual understanding as inseparable from emotional development and ethical behavior. Educational methods that emphasize experiential learning and personal transformation alongside information acquisition. Approaches to truth that recognize multiple valid perspectives while maintaining standards for accuracy and verification. The physical challenges of extreme mountain environments create conditions that test human capabilities and limitations in ways that provide insights into the nature of consciousness, determination, and adaptation. Conditions that push physiological systems to their limits while demanding mental clarity and decision-making capability. Environmental stresses that reveal psychological resources and limitations that are not apparent under ordinary conditions. Natural laboratories for exploring the relationship between physical stress and mental performance. The aesthetic beauty of Himalayan landscapes raises questions about the relationship between human consciousness and natural phenomena that transcend utilitarian function. Environments that inspire emotional responses that seem disproportionate to survival or practical needs. Natural beauty that suggests connections between human aesthetic sense and cosmic patterns or principles. Experiences of natural grandeur that challenge materialistic explanations of consciousness and suggest spiritual dimensions of existence. The collaborative aspects of mountain exploration and research demonstrate human capabilities for cooperation and shared achievement that transcend individual limitations and cultural differences. Projects that require coordination between people with different skills, backgrounds, and perspectives. Achievements that exceed what any individual could accomplish alone, while depending on trust and communication under dangerous conditions. Social processes that reveal human potential for transcending personal limitations through collective effort and shared purpose. The risks involved in extreme mountain environments create contexts for philosophical reflection on courage, mortality, and the value of knowledge that might come at significant personal cost. Questions about when the pursuit of understanding justifies accepting danger to life and well-being. The relationship between fear and curiosity, and how the prospect of death might clarify priorities and values. Whether knowledge gained through risk-taking has different value or significance than understanding achieved through safer methods. The technological challenges of research and survival in extreme environments encourage philosophical reflection on the relationship between human intelligence and tool use, and how technological capability affects consciousness and understanding. How tools and instruments extend human sensory and cognitive capabilities while potentially limiting direct experience and intuitive insight. The relationship between technological mediation and authentic knowledge, and whether understanding gained through instruments has the same significance as direct sensory experience. The Himalayas serve as natural temples where human consciousness encounters conditions that encourage philosophical reflection on the most fundamental questions of existence, knowledge, and meaning. They provide physical contexts that mirror the intellectual and spiritual challenges of pursuing understanding that transcends ordinary experience. Whether the mountains hold ancient secrets that could transform human understanding, or whether their greatest value lies in the questions they inspire and the perspective they provide on human existence within cosmic processes, they remain essential destinations for consciousness seeking to understand its place within the larger patterns of existence. The peaks stand as permanent reminders that the most important human questions might have answers that require not only intellectual investigation, but also personal transformation, physical courage, and a willingness to venture beyond the boundaries of conventional knowledge and comfortable assumptions about reality. As our journey through the mysteries of the Himalayas draws toward its close, the mountains themselves seem to pulse with all the secrets we have explored and all the questions that remain unanswered. Standing at the intersection of earth and sky, these peaks hold their silence like a meditation that spans geological ages. They have witnessed the formation of continents and the birth of civilizations. They have preserved ice cores that remember ancient atmospheres and cave paintings that capture forgotten wisdom. They have sheltered knowledge keepers and hidden temples, protected astronomical observations and medicinal formulas, maintained oral traditions and secret societies across centuries of changing human understanding. The evidence we have examined paints a picture of the Himalayas as far more than simple geographical features carved by tectonic forces and weathered by wind and ice. These mountains emerge as repositories where multiple forms of memory intersect. Geological memory preserved in rock layers and mineral formations. Climate memory maintained in glacial ice and sedimentary deposits. Biological memory encoded in adapted species and evolutionary responses. Human memory transmitted through oral traditions and cultural practices. Each form of memory contributes to archives that preserve information across timescales spanning from individual lifetimes to planetary evolution. The technological mysteries we have encountered suggest that ancient peoples achieved capabilities that challenge conventional understanding of historical technological development. Whether through advanced knowledge systems, alternative scientific pathways, or access to information sources that have not been preserved in mainstream historical records. The evidence indicates that human achievement in extreme mountain environments exceeded what survival conditions should have allowed. Construction techniques that surpass modern engineering capabilities. Astronomical knowledge that anticipates telescopic discoveries. Medical understanding that predates modern biomedical research. Scientific integration that suggests educational institutions and research capabilities beyond subsistence-level social organization. The preservation conditions created by extreme altitude, climate, and geological activity have maintained evidence that might have been lost in more hospitable environments. Organic materials that survive for millennia in glacial ice. Cave systems that protect manuscripts and artifacts from degradation. Atmospheric conditions that preserve astronomical observations with exceptional clarity. Natural archives that function as libraries, museums, and laboratories where ancient achievements remain accessible to contemporary investigation and understanding. Yet as we catalog these discoveries and possibilities, we must acknowledge that each answer generates new questions. Each mystery we attempt to solve reveals additional layers of complexity. Each explanation we propose opens pathways toward deeper uncertainties. The Himalayas resist simple interpretation. They demand approaches to understanding that integrate multiple disciplines, perspectives, and methodologies. They challenge assumptions while providing evidence that supports extraordinary possibilities, alongside conventional explanations. The cultural traditions we have explored demonstrate sophisticated approaches to knowledge preservation that operate independently of written documentation while maintaining accuracy across centuries of transmission. Memory techniques that exceed normal human cognitive limitations. Educational systems that train professional knowledge keepers with specialized skills for information preservation and recovery. Institutional approaches to cultural continuity that prioritize long-term preservation over immediate accessibility. Methods that suggest human consciousness might be capable of achievements that contemporary educational and scientific institutions have not fully recognized or developed. The geographical mysteries we have encountered indicate that ancient peoples possessed knowledge of terrain, climate, and astronomical relationships that required systematic exploration and observation across vast distances and extended time periods. Mapping accuracy that suggests aerial observation capabilities. Construction coordination that implies communication networks spanning continental distances. Site selection that demonstrates understanding of geological stability and climate patterns across multiple generations. Knowledge systems that suggest research capabilities and institutional cooperation beyond what historical reconstructions typically propose for ancient civilizations. The scientific anomalies we have documented challenge fundamental assumptions about the relationship between technological development and environmental conditions. Evidence of advanced capabilities in locations where survival should have consumed all available human energy and resources. Knowledge preservation in environments that threaten the destruction of conventional information storage systems. Achievement levels that suggest ancient peoples developed alternative approaches to science, technology, and social organization that modern civilization has not replicated or fully understood. As climate change accelerates the exposure of materials that have remained hidden for millennia, we face unprecedented opportunities and urgencies for expanding our understanding of ancient human achievement. Each season brings new discoveries while threatening to destroy evidence before it can be properly studied and preserved. Glacial retreat exposes archaeological sites while creating conditions that may destroy them within decades of their revelation. Environmental changes that simultaneously open new research possibilities while closing others through irreversible degradation of materials and sites. The philosophical implications of Himalayan mysteries extend beyond historical curiosity to questions about human potential, the nature of knowledge, and the relationship between consciousness and environmental conditions. Whether extreme environments encourage the development of enhanced human capabilities, preserve evidence of alternative approaches to scientific and technological development, or provide access to information sources that operate beyond conventional educational and cultural transmission. They suggest that human achievement might follow pathways that contemporary understanding has not fully recognized or explored. Perhaps the greatest mystery of the Himalayas lies not in any specific discovery or anomaly, but in their capacity to inspire questions that transcend the boundaries between rational investigation and spiritual inquiry. They encourage approaches to understanding that integrate scientific methodology with intuitive insight, individual research with community wisdom, contemporary knowledge with ancient tradition. They serve as natural laboratories for exploring the relationships between consciousness, environment, and the fundamental nature of reality itself. As we stand at the edge of understanding, looking up toward peaks that disappear into clouds and mystery, we are reminded that the most important human questions might not have simple answers. The Himalayas offer not solutions, but deeper engagement with mystery. They provide not certainty, but enhanced capacity for wonder. They demonstrate not the limits of human achievement, but the endless possibilities that emerge when consciousness encounters conditions that challenge every assumption about what is possible. The echoes that reverberate through these mountains carry voices from across time. Ancient astronomers shared observations across centuries. Knowledge keepers preserving wisdom for future generations. Explorers pushing beyond the boundaries of known terrain. Researchers seeking evidence that challenges conventional understanding. Each voice contributes to conversations that span geological ages while addressing questions that remain as fresh and urgent today as they were for the first humans who looked up at these peaks and wondered what secrets they might hold. If you have been moved by this journey through the mysteries of the Himalayas, consider exploring further. The mountains continue to reveal new secrets with each passing season. Each expedition brings new discoveries. Each research project opens new questions. Each moment of contemplation in the presence of such grandeur offers new insights into the relationship between human consciousness and the vast forces that shape our world. The conversation between humanity and these ancient peaks continues, and you are invited to add your voice to the echoes that will resonate through time, carrying questions and wonder toward discoveries we cannot yet imagine.